Well, thank you, everyone. There you go. So, thank you, everyone, for joining us today in day two for the Jupyterthon. Sorry, my camera kind of moved a little bit. My dog is all over the place in here, so you'll see him popping a little bit in all these areas. But so this is day two of the Infosec Jupyterthon. We had some really good speakers last yesterday, which was amazing to see all the different use cases into how to even use Jupyter notebooks for different scenarios. We also saw some ideas to using some visualizations on the top of Jupyter notebooks. So a lot of cool ideas, and I can't wait to see what everybody else is doing today. We have a couple of things that I wanted to share before we move to the keynote speaker, and it's just all this housekeeping that I will. So I want to make sure everyone has information of the Infosec Jupyterthon. We do have our website, which is the infosecjupyterthon.com, and there's where you can find all the links for Discord. You can find the agenda. You can find also the times. Everything is in Eastern time zone, just in case to remind people. If you're also tweeting or want to follow our Infosec Jupyterthon, you can use the hashtag Infosec Jupyterthon. And other than that, I think that's pretty much what I want to make sure that people has access to. So remember, infosecjupyterthon.com. And for our next speaker, our first speaker of the day, actually, and I think that I could take some of the time first just to talk a little bit about Leo, and then we can move to the keynote in a couple of minutes. But so our keynote is gonna be Leo from Graphistry, which is he's actually the founder of Graphistry. And to me, all the stuff that Graphistry has been doing for years already, it's just fascinating. All this stuff. I actually met Leo, or heard about Leo. That first, actually, one of the first Jupyterthons that we had in 2020, I think it was 2020, 2021. He's been a big supporter, a big fan of the conference, and just to see all the different projects that they have been sharing with the community for years already, it's just fascinating, right? So I can't wait to see what Leo shares with the community today. And let me just share my screen first, so I could actually share a little bit. Oh, you guys could see this is my dog's TV. They're supposed to be upstairs, but it's fine. It's fine to have it in here as well. So let me share my screen real quick because I wanted to make sure that you guys all have this information in here. So there you go. Yeah. So and let me just make sure that I share my screen. And if you can push my screen right there. Let's see. Ian? Can't see my screen yet right now, but there you go. Yeah, so the reason why I wanted to show this is because, as I mentioned before in day one, every single speaker has its own page. So if you want to get to know about every single speaker in the conference, you can go to the speaker section in the website. And you can also see the specific time, the title, and the abstract for all the talks that are going to happen today. So that's something that I actually felt that is super helpful. Like if I'm actually trying to see what this person is going to talk about, I can just look by the name, or just go to the agenda. And when you go to day two, right, February 16th, you can actually follow each one of those. There is also information about their social media if you want to follow them. So make sure that you do that. There is actually some cool presentations happening today. So yeah, something else to remember for this conference. And when I was talking about Leo, because this is part of the introduction, right? Big fan of the conference. I actually saw him in Norway at the beginning of the year, and it was nice to be able to hear some of the stuff that his team and the Graphistry team is actually working on. And hopefully he's going to share a little bit of that today as well. And it's just fascinating to me that how Graphistry is trying to make the graph visualization and artificial intelligence way easy. It's actually something to me that all the things that I'm seeing people trying to do today, like in 2024, it's something that the company has been doing for years already, right? Like building this platform to allow all these different use cases. And we have Leo already here, so it was nice to see you, man. It's been a while. It's been a couple of weeks.
Yeah,
So
luckily a lot warmer this time, so I'm a
yes,
fan.
yes, way warmer. We were in the -18 Fahrenheit, I think it was. Yes, in Norway. That was too much. But as I was saying, Leo, you guys have been doing amazing things. A lot of different projects. I was not aware of some of them actually. We talked a little bit about that. Like, I wasn't aware that you guys were part of the Apache Arrow like initiative, like the whole project. I also learned about other use cases outside of security where graph neural networks understanding structure and understanding graphs and how that applies to the medical field. And fascinating, man. You guys are bringing so much experience from different fields and trying to understand how some of those challenges can be solved with all the things you guys are doing. And the last thing, I also was not aware of Project Domino. Like I actually watched this the documentary, right? That so you guys can learn more about it, of course, in the description of Leo's profile in there. But Project Domino, it's very very interesting. I was reading about it, so um, anyways, and then the other two things also, you guys recently have released how you can use data frames for querying, I guess, in the knowledge a knowledge graph actually in data frames, right? And be able to query that information with something that people are more familiarized with, right? um, so, and then Project Louis. So there is just so much, man. I'm a big fan of what you guys are doing, and I just can't wait to what you guys will be sharing today.
Yeah,
So,
yeah. For folks might be familiar with the like for property graph query language that I think first Neo4j made. They're actually about to go public, so congrats to Emil. But
wow,
yeah, like you no longer need a graph database to do graph queries. You could do it right on your pandas data frames. And so
which
yeah,
that's just amazing. I was trying to do that. I think so I actually tweeted about it. Like I was trying to do something like that in the past, and it was definitely hard. And I'm glad that you guys are also leading that effort, and I can't wait to hear more about it. In general, all these open source projects that you guys are releasing. And with that, man, let's see. Let me just make sure. Okay, so I think we should be good. So with that, man, the stage is yours, and have fun. Thank you.
Great. Yeah, let me do the share screen here. Maybe I do it this way. All right. And can folks see my screen here? Let me actually go this way. Are we good? I don't know if get a confirmation.
Yep, we're good.
Awesome. All right. Great. Yeah. So thanks to Roberto for this awesome introduction. So I'll be talking a bit today about Infosec Gen AI, particularly the claim that Python notebooks are dead. Long live Python notebooks, and kind of what I mean by that. I thought it'd be fun to just kind of situate a little bit before we go into the future. Let's look back into the past a bit. So hopefully folks know who Bruce Schneier is. If not, if he has a Wikipedia page, it's awesome. And even more fun is Bruce Schneier facts. And so here is one about Bruce Schneier. The NSA is actually a backdoor inserted into government by Bruce Schneier. Another good one is Bruce Schneier can read and understand Perl programs. So that one's actually a bit more interesting to us. So I want to do a little example here. And so a lot of today I'm going to be, when we're talking about notebooks, I'll actually be doing it through something called Louis that we've been launching. And so I'm going to start this video here. And so here, kind of like ChatGPT, we're talking to Louis and we're telling it, hey, Louis, use the Python code agent to spawn a Perl process that computes 10 random numbers. I'm embarrassed by how slow I was typing here. Okay. Reads and it should read back the numbers from the process into a pandas data frame and return the data frame. And of course, because the Bruce-Schneier fact, it needs to be well commented, even though it's Perl. And so what we're seeing here is the LLM is looking at our instruction and deciding what to do. And one of the things it's deciding to do is that it's going to be using something we call the code agent. So we actually have multiple LLMs working together, and it's kind of this called agents in this process. And here we're seeing it's generating code. It's not running it directly as you would in a tool like LangChain. It's actually going to generate that code and run it in a secure Python sandbox. And also a little different from a system like ChatGPT, we're actually getting back kind of more like a Jupyter notebook. We got a data frame back that we can now do other stuff with. So let me pause here, kind of at the end here. Maybe this is a good. So yeah, so if we kind of look at screen here, like we saw that we got back the result of the Perl Python process. We generate the data frame, and then it saves the result of the sandbox, put it on screen, and we have identifier for it. But now it's a thing we can work with. As someone who got his PhD 10 years ago on program synthesis, and was even giving talks about program synthesis 10 years ago, it's kind of amazing that like now, the Bruce-Schneier fact has been automated. You no longer need that. So that to me that's been pretty incredible. Let's move on here. So okay, so let's back up a bit. Like, what's going on? So, all right, welcome. I'm Leo, the founder of Graphistry. As Roberto generously introduced, as a day job, I help run Graphistry. So we do visual graph AI for a lot of different investigation use cases. As we mentioned, with like Apache Arrow and also another project, NVIDIA Rapids. We are involved in a lot of projects. But today I'm going to be talking a lot about Louis.ai, something we've been working on for almost probably nearing a year now. And we've been launching with various government and enterprise teams. And for a lot of it's actually just remixing a lot of the Python open source work we've been doing for many years now. And so again, I think Roberto's introduction was pretty great. We do a lot that we put out for free or just to help the community. When I was looking, I didn't really see too many talks yesterday or today on the GPU side. But if you love pandas, I would encourage you to look at one of the other projects we've been involved in and helped start was NVIDIA Rapids, which is basically data frames on GPUs, just if you want things to go kind of bigger and faster without really having to change your code much. And on the open source side, we'll be using a few of these throughout the talk. So PyGraphistry is how we could wrangle data frames, visualize them. PyGraphistry AI, we start doing ability to do more ML and AI on kind of looking at the graph linkages in our data. Again, data doesn't have to start as a graph, like any Splunk result or Elasticsearch or Sentinel is fine. And then we'll talk a bit about the more recent stuff like KuCat and GFQL later. And I did see earlier talks are talking about things like embeddings in UMAP. And so I would really highly encourage you is you can just pip install Graphistry and then use our UMAP visualization. And it kind of does it a little differently and adds in a bunch of extras here. And we'll actually do a couple examples. But okay, so today what wanted to talk about was a few kind of things. So first one, like as we've been working on Louis, and we've been kind of thinking about our experiences with the last 10 years of roughly last 10 years of Jupyter notebooks and our experiences deploying them, and then kind of looking ahead to, based off of those, where we think it's going. And we see it as roughly 3 waves that are happening. Right now, we think we're in an important wave of just kind of the interactive scenario where kind of like in this conference, like it's just more accessible and predictable from notebook environments where we have a human in the loop and we're using the AI to help us author. So I'll talk a bit about that. Then we're working a lot actually on the second wave already. And so I'll talk a bit about things like learning loops and more data pipelines where the LLMs are doing a bit more reasoning and kind of more of a always on scenarios. And then a little more further ahead about scale and autonomy. and those are might be a lot more further ahead than the waves. So okay, let's dig in. So for wave one, um, one of our beliefs is the next 10 years starts with notebooks and Python notebooks. And to understand that, I think it's good to drill in a bit into our or my personal love-hate relationship with Jupyter over that same time, over the last 10 years. So I could say, you know, most people at Graphistry use Jupyter notebooks specifically, or Databricks notebooks, and generally we love them. There are reasons we love them. So, for example, whether we're new to coding or senior in it, it's instant visual feedback as we're doing things that are hard for us. Likewise, open source is great. So I was actually surprised by this. There are almost 1,000 open source packages on pip now, and obviously that includes PyGraphistry, so you should totally install it. But as we're building, what we find really well is kind of these early phases of doing our projects, or if we have a quick thing to look at or investigate or automate. And even within that, as we're doing, even for tricky stuff, it's kind of nice being able to do teamwork. So particularly the markdown support is cool. You can write down what you're doing, and then you can share it with other teams. And so at an individual basis, I think this has all been kind of part of a big, I think a lot of people would agree these are big reasons for the success of notebooks. And starting, I want to say about 7 years ago, I started working with a variety of enterprise and government teams to bring Jupyter notebooks and Python more broadly into their security practice. And there are different reasons that teams are doing it, but generally, as they get bigger, there's a necessity to automate, just to deal with the scale. And then also, as they have all these things like devices, servers, infrastructure as a service, cloud, and growing number of roles, they have to tailor so much. And so having Python as kind of a high level, pretty accessible language for all these increasingly API exposed things has been very powerful. And over the last, I don't know, maybe 5 years, 3 to 5 years, it's become increasingly popular to use Python as part of the detection and especially the data science phase. So as Roberto was alluding, this stuff's becoming more and more normal. We used to be really strange, but now, it's no longer just like the Netflixes and the Dropboxes of the world who do this stuff. It's pretty common. And a way to think about it that I think is useful is Python is increasingly essentially the brain of how security operations work in companies. It's a very rule-based brain, so it's code and it's very deterministic, unless you write buggy Python and it's not so deterministic. But it is sort of a brain that kind of stitches everything together, and that's actually how things work. And like we've all been evolving cool practices for this, and I've seen, like, for example, folks talking about like Streamlets and how they do automation and things like that, and that's actually the Graphistry stack. We do a lot of the same things too. So for example, like what I thought folks might appreciate here is what we're seeing on the top left is like we have a regular Jupyter Notebooks environment. And on the bottom right, we have a regular Streamlit environment for dashboarding. And one of the cool things we do is when we do deployment, you can actually, to edit your Streamlit dashboard, you don't actually have to go into the CLI or anything. You can actually just jump right into Jupyter. We mount them together so that they're serving the same thing. And so you could actually just stay within Jupyter for all your editing, and then Streamlit will auto update. Likewise, like we have like a GPU environment so that your Jupyter notebook has GPUs already set up. So if it works and they have the same base Docker container, so if it works in your Jupyter notebook, it generally will work in your Streamlit dashboard. Same thing with access control, stuff like that. So having all this stuff pre-wired is very nice, and you get the benefit from these massive ecosystems. At the same time, we have burned our fingers a lot, and more frustrating to me is we've gone into a lot of teams and they've hit essentially scaling issues. And while I wish it was scaling issues in terms of performance, because we're really good at solving those, the more fundamentally hard thing, and what I really want to talk most of today about, is scaling from a team perspective and an organization perspective. And I think one of those moments that really stuck out to me over the years about the ability of Python, with or without notebooks, to scale to a modern investigation team. And it doesn't really matter if it's security or fraud or misinformation. It's kind of even like supply chain. We kind of see the same thing. So at that, I'm not going to name the company. I'll just say the person's pretty probably folks here would know them. But essentially, that team was led by a couple of PhDs who loved Python and kind of lived and breathed it, and then 18 analysts who are essentially SQL analysts. And what they were saying was basically one of those analysts, it was very normal for them to write like 1 or 2 pages of SQL just to avoid having to write 5 lines of Python. And that's what I kind of mean as this team scaling problem. That even if some people love Python, there's this challenge of like, how do we do it in a team setting? Because teamwork makes the dream work, right? And so, if we break that down a bit, as we've been working on Louis, there's been a few areas that we've been really thinking about. So, for example, even if we prototype something in a notebook, we really want to move back and forth between the notebook and dashboard, or notebooks and automations, or notebooks and APIs. And it shouldn't just be like a one-way graduation. It should be pretty easy to move back and forth between all of them. And it should be kind of holistic. Likewise, it's actually still, I think it's reasonable for somebody whose background is like maybe IT, or it is like security theory, or they're coming in from the compliance side, or even if they know a bit of code, like if they're not like coding 24/7, there's no real expectation for that to be as natural for them. And so I think it is hard to program inherently. Like it's a thing, it's a skill you have to. It's a skill you have to practice. And even if, let's say, you do get good at programming, it's another entirely different matter to be good at programming under pressure. So let's say you're mid incident and you're investigating something, to be able to just bang out some code that quickly, like that's actually hard. Like that's part of our, for example, our interview process, because we know it's an unusual thing, and there's a lot of people that we would like to hire otherwise, but we know like just types of scenarios we get into, but we know that like that kind of severely limits who we can work with. It's a hard skill. Likewise, in security especially, we know that junior team staff members are really important to most organizations, and that again, that intersection of skills, it's going to take a time for them to get good at this stuff. On the flip side, it's not just programming, but software engineering. Because if you're going to do things like detection as code and infrastructure as code, and all those kind of good practices, now we get into like versioning and testing and deployments, and like how we do sharing. And notebooks are a good step into that direction. But like if you look at, for example, the DNA of Jupyter, like it came out of like bio people, right? Like that just wasn't the need. And then so there's been an ecosystem of ideas and plugins to go at those. But end of the day, it's still kind of hard. And then as you'll see in a theme for today, we're on the extreme end with trying to make security GPU accelerated security data science a lot easier and a lot more accessible. And there's just like a whole lot of other stuff that has to happen with that. And so while we're excited, there's also kind of things we want to think about. And generative AI has been especially interesting here, where we can kind of revisit a lot of assumptions. And so this has been a lot of the thinking for Louis that's been driving into it. And generative AI specifically for Python has an interesting domino effect. So let's say we could use generative AI, as you saw, to generate some Python, and we could be a bit more integrated with what's going on. And let's say we make it a really great experience in the notebook environment. And so we really rethink notebooks from a generative AI perspective. Well, that means we could also do, Streamlit dashboards, or Dagster data pipelines, and all these other tools. We basically get those for free, right? Because we can do basically copy code from notebooks, or hopefully those get redone in generative AI anyway. But that means if we have all this like surface area now redone in a kind of a generative AI way, where we can help a lot of those things that's showing on the previous slide, then that means for a lot of the core things we have to deal with from like a detection or control or compliance side, those are now, all of those surfaces are also now benefiting from generative AI. Now basically everybody on the team is doing generative AI, which is crazy. So if we could do well on Python generative AI, and especially in a notebook scenario, just like the waterfall effect or the cascade here is pretty exciting. So I think doing this moment or this year of doing generative AI notebooks is pretty exciting. Now, as we're doing that, there's this question of how, and I think there's kind of, as we've been getting experience building this stuff, we've kind of learned to focus on two areas that really separate our approaches. The first one is Gen AI first design. And so as we're doing a notebook environment, for example, when you saw in Louis, it was natural language first. It wasn't Python first. It has Python in it, and we do Python a lot in it. But there's this question of like, what's the 80% and what's the 20%? And so by flipping assumptions like that, having Gen AI first designs, we can actually really rethink a lot of these experiences and make them more of a team. Or that's one of our big bets. And the second one, and this is what we're going to talk a lot more about today, is learning loops. And I think today we're seeing a lot of chatbots where people will just, wrap ChatGPT and make it easy to do like a couple of steps. And I think that's great. There's specific use cases. But from the more principled view of like what makes Gen AI really shine is when you can do this virtual a virtual feedback, a virtuous cycle between a model giving you learning things and giving you better results, and then people wanting to use it more and essentially by through a data exhaust training it more. And so the more instead of having a kind of inert rule-based Python bag of scripts being the brain for our security infrastructure, if we can introduce like kind of a learning loop so that the LLMs could learn as we do Python all over the place. To me, this is actually this is going to be sort of like year one for what I would think of the beginnings of the true autonomous SOC, or any kind of like a true brain for the SOC, where we can actually have a system that learns. So we're going to be talking a bit about that. So that's to me that's incredibly exciting. So as a concrete example, we always like to have these little internal challenge problems to kind of be part of our North Star and making sure we're doing things in the right direction. And so one of the ones I want to talk about is how we won last year the U.S. Cyber Command's AI RPE 20. And what was interesting there was it was about a 2-week competition. A little ironically for this purposes here, we didn't realize it was 2 weeks. We thought it was just 1 week, so we came in a week late, but it was okay anyways. But what was our kind of question here is, can we take all of the security data science methods we were using there, and it took 5 pretty good people an entire week to do, and could we get that down to like an hour or an afternoon? What level of automation and streamlining do we need to do to achieve that and make that kind of like just a pleasant notebook experience? And so to give you a sense for the data set and and what we needed to do for that one and what we're trying to simplify, the data set was a pretty regular Fusion Center type one. So think like IDS data. So we had alerts coming in from, it was a shared, I think a CESNet was a bunch of universities, telcos, getting obviously targeted from around the world. And we had anonymized IDS data like honeypots, malware, phishing, things like that. And it was about 1 million from over 1 week. And so the question is, could we start doing great correlation IDs and reduce the billion alerts into a much lower number of discrete incidents that kind of group them and link them together? And so I'm going to kind of give a feel for working with that data with Louis, where what happens once we start connecting the LLM to our database and start teaching the LLM to use tools and things like that. I could increase the playback speed here a little. Okay, so here I'm asking, hey Louis, in the Splunk AVR data, get 1,000 events from a certain cluster, returning all the fields. And so this means Louis ahead of time knows what's in our databases of what are in the tables, and it's able to look at our instruction and decide that, hey, this instruction is actually doing multiple things. It needs to generate the query, but also run the query, and then when it gets the result back, give it back as a table and stop. And so that's already kind of like a nice little like time save. And if you think about from like a data discovery perspective, like if Louis already knows the data catalog, I could kind of talk to it and it can help navigate it. Likewise, while in theory I could have written the Python to get this data into a data frame and wrangle it, coming into a new environment or not knowing all the APIs, this actually is significant. So let's move on with analysis. Hey, Louis, now do a UMAP on the table, where I believe there's talks earlier about UMAP as a clustering. And I'm saying focus on the columns having to do with time, alert category, and IP address. And this is kind of cool. So I'm asking it to do some analysis on data, and I'm not even being specific on which specific columns. I'm just saying which type of columns, because there's probably a bunch of there's probably 6 or 8 different columns having to do with IP addresses. There's probably 2 to 4 different columns having to do with time. And I'm just trusting the LLM to do that for me. Likewise, we try to make UMAP easy, but there's certain tricks to using UMAP. So I'm gonna take a little pause right here. And so Louis figured out which table I'm supposed to use, and then it generated on the bottom the UMAP, the Graphistry UMAP call. And let's unpack that a little. So if we look at the bottom here, for the UMAP call, it's declarative. So we were just passing in which data frame that we want to run UMAP on. It's actually a GPU accelerated UMAP. And so you didn't really have to worry about that because the environment has it. So if we have 1,000 columns or we have 100,000 rows, that's okay. It'll run on the GPU. But what's more interesting here is if you look at the column, what it's doing with columns, it's going to do run clustering on only 2 columns. One is called detect time, and that's probably from the original data. And the second column is called text. And what's interesting with the text is what Louis decided to do was take a bunch of these other columns, like the alert category, the source IP, the target IP, and then mash them all together into one string column. And then we're going to call that text, which is the combined one. And so this is kind of interesting from the sense of we're not just doing UMAP. Well, okay, there's multiple reasons this is interesting. The one thing is Graphistry's version of UMAP will automatically take heterogeneous types of data. So we won't take just numbers, but if you have strings or timestamps or booleans, we'll do the feature engineering to turn those into ones and zeros. And then beyond what the UMAP will do out of the box, Louis decided, hey, if I have multiple text columns, there's an extra step of feature engineering that might be useful to do of combining those into one text column for one categorical analysis. And that's not a very obvious thing. And it's from an API perspective, it's not it's not clear if the API should have done it for you. But from a Louis perspective, where we're actually dealing with the data, it actually kind of cool that the tool did it. And what's more, it kind of explained what it did to me. I can see what it's doing here rather than the raw call. Likewise, when it goes on screen, let's take a look at what happens after that. Now that we have all these alerts and we're running through the UMAP clustering, now we have it in the Graphistry visuals so that we can play with it. And one of the things I'll do is I'll just recolor each alert by the alert category. And so let's slow down here a little bit. So what we're seeing on screen is, again, especially for folks who didn't see the UMAP in the earlier talks, each node represents one of our alerts. And the alerts are placed near other alerts who are similar across any of these dimensions that we're clustering on. And then Graphistry does something a little special here as well, where if any 2 alerts are similar, we will actually link them together. And that's why you see these edges and why we can start treating it as a similarity graph, which rows in our data are similar across one or more dimensions. The more similar they are, the more connected they will be. And again, I did it for alerts, but we could have done it for user agents, for events, or we could have done it for any table, basically. Oops. Okay, yeah. So here I'm just jumping back and kind of finishing the analysis. Okay, let's move on here. So basically, what you're seeing here is an example of where we loaded the data, we wrangled the data a bit, we ran it through a UMAP model. The actual competition, we had to deal with a bit more scale, and we weren't making just one UMAP model, but we made about 20 different ones. And so there's a bit more to what was going on in the competition, but already a lot of the things we had to do, the Louis environments is actually streamlining for us. kind of as Roberto was referring to, we have a bunch of open source projects. Part of the reasons is because we're always looking at gaps in our investigation flow that's needed for us to do end-to-end on a GPU analysis. So for example, and in the event, the one phase that we didn't have running on GPUs and couldn't figure out at that time was how do we convert certain of the columns from text to ones and zeros so we could run all this clustering stuff. And so one of the first things we did after the event was we took a popular feature engineering library and then we added GPU acceleration to it. So it's released as cuCat. But that meant that we can now that we accelerated the data preparation phase, and that's automatically called by UMAP, so you don't have to worry about it in practice. We were able to get the full GPU acceleration. So that means next time, if we want to speed run the event and try to do it again in less than a week, we would be able to guarantee all the data would run on GPUs. Likewise, in the event, we didn't really get as far with visualization as we wanted, but I forgot if I'm showing you here, if I have a video here today on it. But we're able to now, actually, I might have it. I don't. Okay. Well, all right. What I was hoping to show was as soon as you have visualizations and analyses in a Louis notebook, you can actually the thing we launched this month was you can actually immediately turn that into a dashboard. You don't have to write any more code. And so we found that we had to do a lot of work and wrangling in Streamlit, for example, that we're actually we think we could actually eliminate over maybe about 80% of that effort. So that's a kind of a pretty big deal. So we're going to be working more on that over the next couple of months. But again, that accelerates things a bit. I'll be talking a little bit about the continuous learning aspect. And that's kind of one of the next things we think has like hit a lot of the next bottlenecks. So before we get to that, like still focusing on the sort of wave one of like kind of where Python is going in these environments, especially notebooks. I'm gonna kind of review a few things. So one is we're flipping assumptions. So we love having Python in these notebooks, but as from a team scaling perspective, we think it's like Google Sheets, Google Documents. Those are really pleasant to share, and we think notebooks with computation in them can be a lot more pleasant. And so we're doing a few things like flipping it to natural language first. We're adding multiplayer, so it's more natural to have multiple people there. When you open it, it's not like you have to connect to a Python kernel, and if it ever loses your kernel, you lost all of your session data. We're kind of working on making a lot of these kind of major usability issues, especially in team settings. We're trying to right a lot of wrongs, I'd say, or at least in our context, that make more sense to be flipped in their defaults than in the context that notebooks were created. Likewise, we're trying to make it easier to flip between notebooks and automations. Like, could every notebook be an API automatically? Things like that. And then from the Gen AI perspective, there's a lot that needs to happen to actually make that usable. And that's why there's some cool extensions, for example, to add LLMs to Jupyter notebooks. But when we think through things like transparency and explainability and editing, there's just like a lot of extra stuff that we're just not as optimistic about that approach. So we think this is a good time to actually just revisit what it means to be a notebook. And I would say that, still not exactly where we want it to be, but it's already now for the types of programs we could do in it confidently. Already does feel a bit like we've been cured of like Stockholm syndrome, where we didn't realize that we've been having this sort of pressure and weight. But once a lot of that pain of the Python goes away and of working with those systems, it's like this weight's been lifted off your shoulder you didn't even know about. I think to make this really not just for notebooks, but I'm more interested in from a team setting of automation and playbooks. There's a bit more going on, but that's a little out of scope of today. So that's kind of like the wave one of right now. I think just getting the feel for generative AI, especially in these notebook settings, I think there's like a lot of good that kind of cascades out. The next thing I'm going to kind of look at is sort of that next wave of where a lot of these things are evolving. So learning loops and data pipelines is kind of, we actually have a bunch of projects going on here. And So I should note, like, for example, like as we generally do with most of our things, the notebooks for that event, that was the US Cyber Command event, are online in our GitHub repo. And from a like, let's say I wanted to do a speed run and try to recreate it all from scratch, just do it a lot faster in the Louis environment. Well, if that Python code, somebody already put that into GitHub, shouldn't Louis already know it? So that if I talk to Louis and ask Louis to do things, shouldn't it already benefit from it? Like today, we're in Jupyter. It's sort of you kind of have to rely on your memory, and you can't rely on anybody else's memory. Like you don't have this like hive mind benefit. And so, kind of like the bigger question is, what if Louis was continuously learning? Like, if anybody ever wrote or ran Python ever, if anybody ever saw a bug, if anybody ever wrote an interesting query or like found an interesting result, what if our Python environment remembered that, and then we could use it to do all sorts of things? And so this is, I think, one of the most important things for any generative AI system is to figure out how to add continuous learning into it. And so it's about this transition from increasingly I view it as sort of like normal. If you imagine your favorite SOAR vendor, I would view it as sort of inert and kind of dumb and dead. It's just like a stick on the ground. Like it's your job to do stuff. Like your team writes everything and patches everything. On the continuous realm, like our Python rules and whatnot, like the brain should always be growing. And it enables us to kind of do interesting things. So it's just some of the ones that internally, as we're working on learning, we call it learning Louis. Some use cases we're looking at, for example, as soon as you make a mistake and you fix it once ever, whether with the LLM help or your own, Louis should remember that. So the next time Louis generates code, it could automatically fix it on its own. Or if you get stuck, it can do it for you. Or let's say, like, I showed that example of pulling out some data from Splunk and then looking at it with UMAP. If next day I want to say, hey, show some other user's activity or some other IP addresses activity, as long as there's like me or other people have, let's say, multiple actually ways of looking at it, I should be able to just reference it, and Louis should be able to pull that out for me. In the sort of SOAR and SOAR 1.0 and orchestration worlds, somebody would have to hard code that Python, and you'd have to find it, and you'd have to like link it in and call it, and it is just this really painful process of reuse and automation. But if Louis remembered, I could just say, show that user's activity, and I just get it for free. Same thing, like I can also ask, like, well, let's say like for AWS or for Azure, like, how do people in Louis look at AWS IPs versus Azure IPs? By having continuous learning, Louis will know, and I can actually, even if I don't want Louis to do it for me, Louis could actually tell me about those practices. This is all really about automation and code, but it could also be about data. So, for example, who else saw this IP address? Do we ever look at this thing before? Anything like that. There's more that can go here. Like how do you do this in a managed setting, where if all of a sudden you want to, you're in an environment where you have junior analysts and you don't want them to sort of pollute the system, and like there's a lot of important things to actually do this in sort of one of these enterprise environments. But hopefully you're getting a sense of why this would be kind of important. And I think there's like a fundamental thing, like I was alluding to earlier, is if you look at like models of disruption, you want to have something that's kind of big and scalable, and some process that gives you a lot of benefit, and it could just keeps getting bigger and bigger and more powerful than the kind of like the legacy incumbents. And I think we're seeing that here because on one side of the model, we have like a scalable technology where like the more data we throw at something like learning Louis or an LLM or whatever it is, like the more it could learn about how we do Python. And the other end is just users of the system is just better to use because it can do more for us. We'll get more ambitious, we'll just, the more it does for us, the more we'll ask it to do. And the more it can learn from that. And so to me, that's kind of one of those, that's kind of like a classic technology disruption. So I think that's kind of on the other side of this sort of wave two. So that was all sort of about that learning and the kind of interactive scenario. We're also seeing a lot on the pipeline side, and I bet a lot of folks here are having like discussions internally about things like how they could do detection engineering on, like, maybe on their email data or on threat intel reports. So those are kind of common things we're seeing with some of our users. I'm going to do an example here, a little more intense and a little outside of cyber. So it's emergency scenarios, but in the physical world. So we're working with the U.S. government and one of our partners, Disaster Tech, really cool company. And we're looking at scenarios like power outages and hurricanes and winter storms. And if you think about the incident responders in those cases, well, before the events, you do have, the 24 hours before a hurricane lands, there's a lot of stuff that has to get figured out, like checking on your first responder partners. Once the lands and things are going on, like, let's say the power grid goes down, there's a lot of situational awareness. Nowadays, especially with the technique I'm about to show, there's the misinformation side. There's a lot going on. So what we've been looking at is, today a team might, when they're gathering open source data and kind of broader data, they might have a TV on, they have the news channel on, right? Like, that's how they get the news. And that's not really great, right? And so what's been exciting with this LLM stuff is, like, we can realize that as we're writing our data pipelines, we could actually look at real time. We're hooking into 55,000 newspapers. We're hooking into the Twitter fire hose. We're hooking into like cyber feeds, or especially around like government scenarios, like imagine like around the grid. And from an emergency responder who's worried about, do we need to buy bottles of water? Do we, like if the power grid goes down, like which equipment do we need to focus on? It's unrealistic to look at all this stuff. But with LLMs, we can actually put stuff in the middle, and now we can start thinking about new kinds of use cases. I wouldn't really want an emergency responder in a notebook, but maybe they could talk to it. Or more realistically, could I get an automatically generated hourly sit rep? Or can I get a morning brief? Or if certain things happens, can I get an alert? And so a lot of those things are becoming possible. And I wanted to look at it a little more from a Python perspective here, and more of like an implementation. So because folks are building their own detection pipelines, like I think they'd see the similar thing. So here I'm doing an example of, hey, Louis, in the emergency Twitter news index, in this case, we have it in OpenSearch. What is there to know about the fires in Maui? And what behind the scenes Louis will do is, when it does code generation, it does neurosymbolic. So that means we'll generate both the regular, in this case, QDSL, but also the embeddings. And so you see at the bottom there, we have these, like, it's generating the way it represents fires in Maui. It's probably using encoding that as a vector. So maybe it's like maybe a 300 dimensional or 1,000 dimensional list of numbers. That means it'll do a match against not just fires, but maybe if people talk about like burning or fires in Maui, is actually like, maybe that's like actually more of like a concept. So maybe there's some like fuzzy events. So it's no longer a keyword match. And then it gets back the results. And then not only do we get the results, but we get the summary, right? And so we're able to build these things. Where I wanted to go with that is, part of the reason I'm saying this is sort of wave 2 versus wave 1, like we do have teams building these, but like not that many. Like it's a little too hard for most security teams to build something like this. But basically, instead of just talking to a database where you might have like Databricks with its data catalog, we're actually doing data preparation, where we're actually, kind of like for the UMAP I was showing for the alerts data, we're actually turning them into embeddings ahead of time. So those kind of libraries that Graph's been working on all this time. And we're actually doing it in, we're starting to get ready to do in much more interesting ways, where instead of just a direct search result like I showed you before, there's actually other kinds of linkages and things you want to do. And so we're kind of in the middle of this second wave, where I think for a lot of teams bringing generative AI to their Python practice, I would start with the notebook type stuff that I just showed you. But I think this is very quickly, once you start dealing with data, this becomes like the next step, is starting to decide which ones you want to do this way, so you can just get better results. And so kind of what we're seeing here is, like, when we come in, we try to bring in a lot under the Louis umbrella, just so that's like a lot built in and does a lot. Like, it can run Python in a sandbox, it has dashboards, all that stuff. But when we walk in, teams generally today, they might have the regular database like Splunk or Databricks, maybe even a graph database, like that's all cool. And then they might say, you know what, I want to take one of our database tables and now turn it into a vector database or vector index in OpenSearch. or we have this really important internal tool, and I want to have the LLM able to use that. And so kind of we're seeing this phase right now where folks are either in the interactive scenario or more ambitiously in this always on scenario. Like I think that is kind of this wave too. And kind of like last slide here, as we're kind of in this middle, like first wave, second wave, we're already seeing what the third wave looks like, but it's definitely very experimental. So we're seeing things like multimodal scenarios. Like imagine when let's say we're doing a fraud investigation and we know that somebody's logging in from an unusual country. What if the LLM knew not just text, but actually knew how to use a map, actually knew how to use like Google Maps or Google Street View even. So there's cool research happening there. Likewise, what if we could just put the database into our prompt? So could we scale these things up to deal with more tokens? That's still kind of cost prohibitive, even if you can, it doesn't mean you should. But we are seeing, for example, a company I'm really like admiring right now is Grok. If you go to grok.com, they actually made special hardware. So instead of using GPUs, you have this like ASICs that you can basically take like the regular open source models, but you can run them 10 times faster. That has all sorts of implications. Like, for example, if you want to work not on alert data, but on event data, so it's just like wider and more of it. There's just like a lot of interesting things. So I think that's like we're already seeing a lot of that stuff happen. I'm actually probably like underestimating like combine those two things, you're already 100 times cheaper or 100 times faster, however you want to say it. And again, that's probably like underestimating. But on the other end is autonomy. And I know like people like to, speculate about it, and definitely the marketing people. But from a practical view, what I see is kind of like two types happening. What I showed you today was going from that single step text analysis to multi-step agent reasoning. So for example, we can ask Louis to get some data and then visualize it. That'd be like a two-step process. Or to get some data and then based on what it is, decide what's a reasonable next step. That'd still be a two-step process. But instead of me telling it what the next step is, it actually decides what the first step is. And then more ambitious is like if you have it just like fully autonomous, like an always-on threat hunting thing. I probably shouldn't in this venue talk about like what we've been experimenting with there, but reach out to me and I'm happy to talk about that. Like I actually do think there's certain scenarios where this stuff gets pretty interesting. But at the same time, I'm not. These are kind of like analytical scenarios, like detections and alerts. Historically, something like SOAR, like security orchestration, has not been. People have been very much more. Let's say I don't know what a good word is, like tame in the actions that they allow an orchestration to do. So like you don't want to just like turn off the CEO's laptop, things like that. Like they're just like. Oftentimes for serious decisions it needs to go to an analyst to make that call, so it's more about like alerting than actual, or more about just like ticket management. And when we think about autonomy, like I would expect something similar. Like maybe there'll be more use cases that fall under, but at least for our team for now, we're focusing more on that wave 1, wave 2, just because we know teams can get rolling now. And then before we focus on the action stuff, we do want to do it for some scenarios, but mostly that reasoning, we think. And so if you think from like a multi-year perspective, kind of getting a sense. Anyway, I think we're a bit over time. So I guess thank you, Roberto, for being patient here. Few things, just the wrap up. Gen AI is coming. I think notebooks is a great place to start. As soon as you can think about learning loops and data pipelines, like I think that's that next level of kind of cool. And you are getting that sense of the higher stuff. But then more practically, if you just want to do things, go to the PyGraphs3 repo. We have a ton of notebooks, including most of the stuff I talked about here. I would especially, UMAP is like our graph visualization is classic. If you saw any embedding worked at other talks today, I would encourage you to try doing it via UMAP. It's just a little more automated and a little more scalable. It's just kind of more both easier and more stuff. And then for the more adventurous, we are launching our graph query frame language. And then, of course, for Louis, we are starting to bring in more folks into it as well. So, yeah, a lot of stuff. hopefully it's worth it.
Yeah, a lot of things. I mean, you guys, once again, you've been doing a lot of cool stuff, and how a lot of the things that for example, that I keep reading about the community around Gen AI and the things that they want to do, and what company, and you guys are already, building, I think, the first agent that is actually interacting with a lot of the data sources, different platforms connected. Amazing. I can't wait to play with Louis. I haven't played yet, so I'm definitely gonna reach out to you and see if we can do something quick. We're, of course, like, right, way over time, but there's a couple questions in the Discord channel. So if you have some time for those, that would be great. Two things that I wanted to highlight in here is the continuously learning piece of what you guys have built already, and of course, you're developing. It's I think it's a big challenge, right? To have all this happening as the data it's flowing, generating generative AI data pipelines. It's a big challenge, and to see you guys already trying to figure out like how that should be done, the future for a lot of the stuff for real autonomous agents. It's amazing. 2024, and we're already talking about that. 2022, I was thinking like, yeah, maybe a couple years, but it's just impressive. So thank you so much, Leo, for your time. Once again, you're a big supporter and coming to the conference and always, sharing your knowledge every time we do one of these. I do appreciate it and hope to see you in the next one. So
yeah, and I'll just answer the questions in the Discord chat. That might be a better, more respectful way to do
yeah, that sounds good. Thank you very much, Leo. Appreciate it.
Thanks, Roberto. Always a pleasure. Enjoy.
Thank you. Take care. All right. So it's funny, I was saying bye and I was feeling like I was stopping my Teams calls or anything like that. But we have Luis. Luis, how you doing, man? And I think we have also Ashwin joining us to the conversation. Let's see. Oh, there you go. Yeah. Thank you for joining us, Luis, today, man.
Nice to see you.
Hey.
Hi, Ashwin.
Hey, Luis. So hope everyone is enjoying the keynote. I think that was an interesting keynote. So I'm welcoming Luis. I think Luis has spoken in the previous conferences as well. So it's always bring like interesting analysis. I think today's talk seems to be interesting as well. Like I've used the Bloodhound Neo4j interface mostly, and then not the API and the Jupyter side of things. I see like some work has happening in that space, but I'm looking forward to this talk. So yeah, Luis, over to you.
Thank you very much. Let me share my screen. Yes. Okay, it's okay, right? Okay. First of all, for sure, thank you very much. It's a completely honor to be here, sharing this time with you. It's one of my favorite congresses by far, because I love the topic itself. Jupyter is an amazing tool, and Jupyter, how the people is using Jupyter notebooks inside the cybersecurity, it's amazing, and it's always a pleasure to be here learning from all our colleagues. Okay, let's continue. First, my name is Luis. I'm responsible for the Active Directory and Endpoint Security in the European External Active Service. It's a diplomatic service of the European Union. And previously, I was working in incident response, doing a lot of data analysis for firewall logs and things like that, and other fields in cybersecurity. Today, I would like to talk with you about Active Directory, about directory security, and also about the topic of the cleanup of the Active Directory, trying to follow a zero trust approach. And just a little bit introduction. I think that the majority of you are used to work with Active Directory, but in resume, it is a database of objects. These objects are users, groups, computers, group policies. And what is maybe even more important is that inside of this database, we have the relation between these objects. The relations provide us an interface to manage the rights to access from some resources, also the rights to modify other objects. And this is a key element because around the Active Directory is constructed every other service. In the majority of the institutions or the organizations, it's really common to have the Active Directory like a central point for identity and from rights management. What it means that at this point, Active Directory is like a ring that can control all of the other service. If you are able to compromise Active Directory, if you have enough rights in Active Directory, you can manage a lot of services. Even you can even compromise the entire institution, the entire organization without any issue. This is the introduction. Let me a little bit of situations. Imagine that we are in a medium of big organization. We have thousands of users. We have hundreds of GPOs, service accounts, IT supports, IT admins, a lot of kinds of different administrative users. And we are having a lot of fun with identity. And one day, someone, maybe us or maybe our manager or one auditor, start asking simple things like, do we have our administrators identified? Do we have good policy for identity right management? On can attackers abuse or configuration in Active Directory to escalate privilege? And because we have a better background, we know that these questions are coming with much, much more complicated questions. Like, what the hell does administrator means in Active Directory? That is not clear at all. I mean, if you can modify, if you can own different objects in the domain, it means that you are an administrator or not. Only people inside domain admins are administrators. Does anyone in the organization really understand how permissions work in Active Directory? Because it's not that simple as in the beginning the people can think. Also, the service owners are able to identify the needs of their projects, or they did it in the past. And at the end, honestly, it's super complicated. And at the end, nobody has the right answer for these questions. And then you have to try to find if there are in the market tools. It's not a reality right now. Some companies are doing so really well, like for example with Bloodhound, but it's not so common to find. It's not easy to find an application to be able to really understand your Active Directory and to be able to start cleaning or start follow the good practices for Zero Trust in Active Directory. Then we can start. My approach for that, my proposal is to use Bloodhound with Jupyter notebooks. That in this case, the Bloodhound Community Edition that is almost brand new, and it's an amazing tool for sure. I really encourage not only attackers, also defenders to use Bloodhound. And like for the data, I will use this game of Active Directory that is a testing environment coming from Orange Cybersecurity. It's an amazing project. If you are in the offensive part of Active Directory, it's a must. But even if you are in the defensive part, it's amazing this project to train, also to have data to work with. I will not go deeper in the code. I will use for sure Python and Pandas, these data analysis libraries. And first, know yourself. One of the first things that we can do with Bloodhound is to know better our environment. In this case, we have 3 different domains. One is the 7 Kingdoms. This is based on Game of Thrones. And one of the things that we can see here is that even one small environment with 15 users, for example, domain 17 or whatever, there are thousands of relations, thousands of ACLs that provide rights for other objects. In a realistic environment, we will find something like this. I hope it's visible. 57,000 users, 7,000 groups. And when we are talking about ACLs or relationship, we have millions. It's super complicated to know where we can start, where we can start understanding our environments, because usually everybody is starting from the top. You start analyzing the domain admins, schema admins, enterprise admins, but it's true that in an Active Directory in a big company, it's much, much more complex. And at the end, you have a lot of service accounts, a lot of groups that are completely overprivileged. Then we can start asking Bloodhound for our users. It's super fast, super simple. Then we have a pandas data frame to start filtering if we want. But something that is super cool coming from Bloodhound is that we can ask Bloodhound about the number of objects that every user can control. Just this is amazing, because to check this in a Microsoft environment, it's super complicated, because you have to go object per object, checking write per write, and to do it with PowerShell for me was like a nightmare. And with that, with this, we can have like just a simple list of users. We can sort them for the number of objects that they can control, and we can start knowing what are the most privileged users in our domain. And this is super cool. But we can do the same with the groups. That is also almost maybe more important than the users, because at the end, is the most common is that the rights of the users are coming from the rights of the groups. And in this case, for example, we can see that the most privileged user was Robert Baratheon. That is the king of the Seven Kingdoms, and makes a lot of sense. But when we ask for the membership of the groups that Robert Baratheon is part, we see that in this case are 13. In a real environment, you will have like 200, 300, 400 groups. And for that, it's super complicated to know from where this user is receiving the privilege. And now that we have the information coming from groups and from the users, is super easy to correlate both and to know that in this case, Robert Baratheon is getting the rights for 286 objects because he's part of the domain admins. That makes sense. But in a lot of cases, we will find that the users are part of groups that we were not aware, or that there is not common, or it was a stopgap solution because it was an IT guy that put his user in a group just to fix an issue, and at the end, the membership continued there, and they start growing and growing the rights of the user without any control. Other good query could be users that are not tier 0, that they have a path to tier 0. Tier 0 is a way to identify over sensitive groups or important groups in the domain. And how Bloodhound is working is they are also not only identifying the sensitive groups, they will know like domain admins, schema admins, backup admins. They're also putting this label to users that are part of this group, or that they have a hard relation between them. And this is super useful because in this case, for example, we can execute this query to know users that can control another objects in the tier 0. This, if you execute this type of query in Bloodhound, in a real scenario, it's possible that you reach a timeout. But if not, you will have a huge graph. And sometimes because the attackers only need one hole to go in, but the defenders we have to cover all of the holes in the environment. For us, it's nice to have a list of users to start working with, also to fix one by one, also to know better why they have these rights. And also, in this case, we will search for not tier 0 users that can control the domain controllers. For example, here we will execute the query, and we have several users. But what is also for me it's super useful is trying to know the number of edges that we have there are between the user and the destiny. In this case, for example, if you see Stannis Baratheon, he only has one edge. It means that the relation between both objects is super close. But in other cases, like Lord Varys, the relation is much longer, and we will see that for example, in this case, if we check the attack paths between two objects, in this case, if you search for Stannis, we print it, we know that Stan has generic all rights over the domain controller. But if we search for the other that was Lord Barry's in this case, this is something that I think that nobody wants in their environment. In this case, we have the Lord Barry's is able to control the domain controller, but without a direct relationship. This is something that we have to fix because there are not direct relations that are super complicated to control, and it's these are the things that we want to discover in our environment to start cleaning. There are another simple search. For example, we can use the AP calls to ask for users, much simpler than with PowerShell, for example. Searching for users, we can filter, we can modify the data with pandas. We can ask for users that has SPMs. We can execute these queries. Also, it's pretty useful. It's users that was never used. They were created, but were not never a logon. And it's possible that these users are still with the default passwords that the IT people sometimes are using. And there are a lot of ways to find this. Like results, with that, we will have much more visibility. For me, this was a super quick win because pretty easily we were able to identify a lot of issues in the domain. We can start with a cleanup plan that is super useful and easy to follow instructions for sure. Jupyter notebooks are incredible to create documentation at the same time you're putting code. Also, you can modify the code based on the results. It's incredible. Also, we can document the process and we can easily resume the investigation day by day, and it's the best. And as always, my advice: please use more Jupyter notebooks and less Python or messy scripts, because the difference also not only for you, also for the others, it's amazing. There are another use cases that I would like to cover in the future, but at this point, that's all. I'm trying to recover some time. I don't know if there's any question, please.
Yeah. Well, first, thank you so much, Luis, for sharing this. I love that you kind of like went through the process that I think a lot of folks were probably also trying to do, which is you go from Neo4j database. A lot of people use the database, especially Bloodhound, right? Like the front end and all the stuff. But there is a lot of additional like analysis that you can do, right, on the top of that knowledge graph, like using pandas and trying to like mix it up a little bit, right? Like graphs and tables, but it's super powerful, right? It's not to substitute, like to say don't use the graph, but I think to me, I love how you mix it up. And I think that a lot of people have probably been thinking, how do you use Jupyter notebooks with structured data, right?
Mm-hmm.
So I think there is one question, well, it's actually from me. And it's like, how do you, so I guess my question was probably answered with one of your last visualizations, but I would just say it anyways. Like, how do you go from knowledge graph or like graph visualizations to data frames? And do you go back, like when you run your query through your notebook and you get a data frame, do you try to visualize that again just to kind of go from tables to visual? Like, how does that? How do you do it? Yeah.
For me, the useful part is honestly to work with the data frames, because at the end you have a lot of data. When you are working in a real environment, the issue is that you have too much data. And maybe it's the big difference when you're working with graphs. The graphs, you only have to find a path. But when you're working in a real environment, you have a big table. And for me, going one by one is super useful, because you have to start fixing all of them. Yeah. It's not only needed one, you need to go through all of them and create visualization just one by one, taking into account the nodes and the edge. it for me was the most useful part. Also doing it in Jupyter for sure was super useful.
Nice. And I think that, so I know that there is a saying that something that was said right by John Lambert from Microsoft, that attackers thinking graphs and defenders thinking lists. So I know that is more related to identifying connections, like identity-based connections in the environment. But when it's come to analysis, it's a mix of that, right? We're thinking graphs to identify certain interesting paths, and then in the process of analysis, we trap the tables to do some other type of analysis, and then we can go back to do graphs. So it's a combination of graphs and lists.
Sure.
Yep. Awesome. Thank you very much, Luis. It was my dog just moved my whole stuff. These guys are crazy. Anyway, so thank you so much, Luis. It was great to see you again, once again in the Jupyterthon, and I'm also happy to hear that you find the conference, something that you want to speak and also see every year. So thank you so much. Hope to see you next year too.
For the opportunity.
Awesome. Take care.
Bye.
Thank you so much for an awesome talk, Luis. That was super interesting to explore Active Directory in that way. So thank you so much for your time and presenting for us.
Thank you.
Up next, we have Xavier Moragat. He is going to speak to us today about a really interesting topic. I was really interested by this by reading the abstract. He's going to talk to us about OSINT exploration. And he's going to go into the nuances of the powerful information gathering technique and offer some insights beyond the conventional approaches that we might have read about online. So take it away. Thank you so much.
Hey, Xavier, we can't hear you. Do you have your mic's not muted?
Okay.
Cool.
Yep, now?
Yep.
Can you hear me? Yeah, nice. Okay, so as I was explaining, let's imagine we are all a bunch of happy analysts, and we are tasked to profile our own organization and employees in terms of internet exposure, in order to mimic what an attacker will do to detect the low-hanging fruit. So one part of our mission is to try to get emails and names to see who could be a good target. So yeah, we could do this task by crawling the entire company webpage and scraping all this information, but we don't really want to create so much noise. Another way to do it, another approach, would be to visit LinkedIn and try to search people from that company. But, well, however, these types of platforms have some protections to avoid scrapping. So, yeah, although there are some ways to bypass those protections, today I'm going to talk about one that I really like, Google Docs. So, yeah, my name is Xavier, and I'm a cybersecurity engineer at ITUCAT, an innovation and research center here in Barcelona, Spain. We create innovative prevention and detection cybersecurity tools based on user and entity behavior analytics. And what I will show you today is part of a project where I created an OSINT tool called Infosec that allows users to profile web domains and companies in a passive way. So, but firstly, let's see and remember what Google Docs are. So for those that have not heard about this term before, this is just how or what it is. So docs are just advanced queries that you can make on search engines, but it's not just asking for a list of emails, but instead using some rules. For example, when using quotation marks, that is one of the rules that you could use. And we are telling the engine to show only emails, well, not emails, but only results that contain that word. But yeah, there are more things you could do to refine your search, and that is by using tags. with them, you can specify where that word should be. So, for example, if you are using, if you want to search for results that contain the word admin in its URL, you will need to use the tag in URL. So, for example, here in the screen, you can see that when we search by using that dork, we are getting, in fact, only results that has that word in the URL. Another example would be to use the tag in title, and in that case, the word admin will the results will only have the word admin on the title. Okay, so yeah, well, it's worth not mentioning that even if I call it Google Docs, this will also work with some adjustments with other engines like Bing. Well, nice. So now that we are kind of on the same page, let me explain how we could get people's names from LinkedIn without really entering to the platform. And obviously, that would be by using docs. So as search engines crawl over the internet to serve results based on a query, we don't need to scrape those pages anymore to get what we want. So we will just need to craft a specific door that will give us the exact information that we desire. So for getting names from a specific company, we could use this dork that I have created. And let's see what exactly is happening here. So first we have a tag that is site. And with this, we only will get results from that domain, in this case, LinkedIn. And the other tags are negative tags that are using the minus character in order to exclude all that terms from the results. So here we are just getting profiles from the target. So as you can see, the target will be in quotation marks in order that that word appear on the results. So the good thing about this approach is that search engines have APIs, so we could automate this process very easy. And in this exact example that we are using LinkedIn or other social media really, in the response we will get meta tags on each result that will allow us and will give us names, so we don't have to parse anything with regex, for example. That can be a little bit tricky. So, for example, here we have from the dork before that I used that I tested against i2cat. You can see that this is the JSON that will return for a specific person. So we have the profile last name, profile first name, and even we could get the image. So as you can see, there's a bunch of information. And also, we could also extract the username. So we could, in our investigation, try to see if that username appears in a leaked database. But, well, that's another talk. So, well, I have created the notebook using the Google API, and there is a limit of 100 results from the same query. For example, here it's what I got. It's an example, but you can get the idea. Here we could get a maximum of 100 results for this limitation that I mentioned. But, well, we can try to be a little bit creative and try to get even more results. How? Well, we could add in concatenate in the previous dork the role. Okay, so we could use a role and say, for example, engineer, administrator, CEO. All of that will produce results, and even we could get 100 results for each of them. Okay, so for emails, yeah, that's a bit more difficult. As search engines don't want to expose personal data, or at least that people can search for emails directly. So we have to think about how we could do it. So the following docs have been crafted in order to get or to try to get emails. So as you can see, there's another new tag, there's the in-text. So that word will appear in the content of the web page. And then we can use the OR logical operator that will give us some files for file types or from other sites or URLs. So with this, we could extract quite a lot emails. But of course, this is just some of the docs that we could use. If we use more, the more we use or the more we execute, the more we will get. As you can see here, yeah, you will get probably false positives. Well, not false positives in this case, but maybe on the names part. But here you will get a lot of repeated emails. So yeah, that will be like a thing to take into account. So yeah, now that we have the names and emails, how can we try to match them? So we have names on the side and emails on the other one, and how could we create relations, right? So well, again with docs. So imagine, well, you don't have to imagine. This is my i2cats email, and as you can see, we have two parts, right? So we have the username, xavier.marrogat, and the domain, okay? So we could separate that and try to create a doc that uses between quotation marks the username and then the scope. So with that, if we are lucky enough that the company, the target company has this format on the email, of course, we will get maybe a LinkedIn or a Twitter account on the results. So we can easily, again, use the meta tags that we saw earlier and extract the name. So if we have the name, and if that name appears in the previous list that we got, then there's a match. If not, we can create, and we have discovered a new person. So yeah, so now that we have names, in fact, and emails, now we can further investigate who is really the low-hanging fruit of the company. So, well, to sum up, docs can be really helpful to X-ray websites, as engines have the most content already cached. All these docs can be found on the notebook that I will show you now, that I created for this talk, and in the InfoHound tool that I mentioned earlier. So if you have any questions or you want to discuss anything, I think I'm on time, but I don't know. So yeah, thank you for having me here.
Thank you so much for that super interesting talk. I think seeing the use case of getting all those emails is super interesting, and all those LinkedIn links. I feel like that is such a useful and powerful way to use this. And that's something that I never thought about. So getting to witness that is something super interesting. I'll definitely look at the notebook after this talk and dive more into how you did that. Because I feel like that's just a super interesting way to play around with that. Unfortunately, we're cut short on time, so we don't have a lot of time to ask questions. But if anything pops up in the Discord, feel free to take a look and answer anything that people are asking.
Yeah, sure. I will take a look now.
Yeah, thank you so much for your time and chatting with us. Up next, we have Fred Beguelin. He's discussing today a demo using Yeti in a notebook and highlighting some Python libraries to explore graph data using Yeti. I've heard a lot about Yeti online, but I haven't been able to really dive into any particular notebook examples. So I'm personally really excited to see what Fred has to say about this.
Hello, good morning, good afternoon, good evening, maybe. Thanks for accepting my submission about hunting the Yeti on Jupyter, a practical exploration of the Yeti platform using Notebook for threat intelligence. So at first, who am I? Frédéric Baglin. So I'm a senior security researcher at Datadog, and I worked in the past in digital forensics, incident response, and threat intelligence before joining Datadog. And now I'm a security researcher since 2 years, mostly. So yeah, briefly, Datadog is also very well known in the DevOps side for observability in the cloud, etc. And also more and more focusing on security and providing lots of different products around security. So the talk here is to discuss how I would like to be able to hunt on my telemetry from the different customers, and also by leveraging my threat intelligence database. So as a security researcher, I want to visualize cyber threat intelligence to define hunt hypotheses. So the idea is to render visualization, to be able to quickly find potentially outliers and also highlight trends. So we'll have some example later. I also want to hunt my telemetry based on IOCs, so indicator of compromise, and indicators as well. So indicators means, for example, based on Sigma rules, regex, etc. And finally, around the TTPs, so technique, tactics, and procedures. So the idea behind this is to, for example, from the name of an intrusion set, so let's say Team TNT, for example, I would like to automatically look for their tooling, so hashes, file paths, but also for their infrastructure, about their payload delivery, C2, domains, IPs, and so on. And finally, I want a feedback loop and share my results. So based on the different hunting findings, the idea is to re-inject the findings after review into my threat intelligence database, and then share the content with my colleagues. So how to do that? So let's keep it simple, stupid. The idea is to have an interface connecting my telemetry with the different logs, traces, security signals, and so on. And on the other way, my threat intelligence platform, which aggregate the different feeds, articles, honeypots, and manual inputs that I can add inside my database. And that will make me happy, of course. So for the threat intelligence platform, we are using Yeti, which means your everyday threat intelligence. So a quick input on Yeti. So in a nutshell, so it's an open source platform which aims to bridge the gap between CTI and DFIR practitioners. So providing different types of intelligence, ranging from classical IP domains, but also more cloud-focused one, and also aggregating the different entities we can find in STIX taxonomy, for example. So the different let's say intrusion set, TTPs, etc. And everything is directly stored in a graph database. So earlier I heard someone talking about attackers things in defenders things in list and attackers things in graph. So the idea here is to also think in graph. Yeti is also able to ingest feeds of observables, but different type of information like MITRE attack techniques, for example. So it's to map all the different information, but also LOLBAS and so on. So we'll see. I will just show you just after a quick demo of Yeti. And finally, Yeti also provides a way to query unified and validated data thanks to open API specification. So it relies on fast API and Pydantic. So quick demo. So that's my demo instance. So the project is fully open source, and you have the link directly in the slide. It's directly on GitHub. So here you have the different observables. So as you can see, you can add any type of observable like that. And then you have all the concept of entities. So with the malware, the tools, so it comes from different feeds, the different attack patterns. So this is the TTPs. We also have intrusion set, the different campaigns we are working on, identities, vulnerabilities, and so on. And in fact, the idea is to navigate and easily between all of this. So for example, if I click on reveal, I will have all the description of the reveal malware.
Fred, sorry to interrupt. Could you zoom the browser a little bit? Could you zoom the browser a little bit, because the text is a bit tiny? Thanks.
Like that?
Perfect. Yeah, great. Thank you.
So here we have the different attack patterns, the different intrusion sets. So for example, if I click here, I will just pivot to the FIN7, etc., etc. So that's the main idea behind Yeti. So to represent everything as a graph database. And this is one example. So this is the ArangoDB backend. And here you have all the information as a graph. So let's go back here. So we have our threat intelligence platform. Now we want the interface. So of course, we will use Jupyter notebooks. So why Jupyter? Because it's possible to do live data analysis and visualization with Python. We can also connect data from different services. So here, the idea is to connect my threat intelligence platform and my telemetry backend. We can also share and reproduce the hunt, the visualization by sharing the notebook with colleagues. And finally, it's also very useful for rapid prototyping. What about visualization? So we have different ways to represent the threat intelligence. So for example, statistics to highlight outliers. So here the idea is to rely on data frame for the data frame. And then we can use renderers like Plotly or Bokeh. We can also map IP addresses, for example, thanks to a choropleth map. So I'm not sure about the right pronunciation, but anyway. Here the data layer will rely on data frame with including 3 letters country code. And finally, we can render still by using Plotly or Bokeh. And the final visualization we are interested in is graph layout. So here we have different type of data layer. So we can still rely on data frame, but there's also some other open source project which helps to generate graph visualization. So at least represent graph that will be used by the renderers. So with NetworkX, for example, and also JSON. So for renderers, we can still use Bokeh. There's also other open source project like IP Sigma and also Cytoscape. And there's also more project, of course, but that's the main one we have identified so far. So now the idea is to demonstrate what's possible to do. So this is the notebook. So I won't reinstall everything because it's already installed, of course. Here, just the import, so loading Bokeh. We have different type of enrichment. So ideally, it's also possible to directly use Yeti to add the geolocation IP address. But here we are just adding some content based on the circle cert, which gracefully provide this in the different database, geolocation database. So let's enable it. Then we have the part for the visualization. So here it's to render maps based on our IP geolocation. So as you can see, we are just using a data frame here. And so 2 examples, one with Folium and one with Plotly. And regarding graph layout, so as you can see, there's several ways to render a graph. So the easiest one is with IP Sigma and by using NetworkX data layer. And then you have the exact same thing. So the idea is to also render the graph database with Bokeh. So as you can see, it's quite more complex to do the same thing with Bokeh. So yeah, IP Sigma is a good one, in fact. Then we have all the Yeti API information. So I will just collapse this one. And then, so let's do our visualization. So here I'm just creating my Yeti session. So connecting to my Yeti instance. Then the idea is to provide is to display some information about the different tags we have currently in our database. So here, as you can see, we have lots of C2 but also, for example, Docker exploitation. So I will focus on this one now. So here again, I will just query tags containing the name Docker. So as you can see, Docker exploitation, Docker Hub, Docker entry point, and so on. So all these tags comes from our Docker honeypots. So we are aggregating all the logs which are located in our dedicated Datadog instance to parse the different honeypots we have deployed. And then we aggregate everything directly in Yeti by creating some graph relationships between, for example, a Docker image, an IP address, and etc. So we'll see what's it looks like. So here, what I'm doing, I'm just querying all the IP addresses related to Docker exploitation tags. And I will just plot the rendering. So here the example is with Folium. So as you can see, it mainly originated IPs are mostly coming from China. So this is one example with Folium, and we have the same thing here with Plotly directly. So yeah, that gives a pretty good overview of what's happening and what's the source IPs targeting our honeypots. And yeah, that can be useful if you want to share this type of information with top management or when publishing an article. Then we can also render some mind maps. So here the idea is to create a mind map. So generate a mind map. Oh, okay. No problem. Let's just comment it. So generate a mind map based on an IP address. So just having all the different information. So, okay, so that's not the best way to render it, but trust me, this is a real mind map. I think I saved one here. I'm not sure if, no, it won't work. I think I had an issue. So that's not the best example, sorry, but let's move to the graph layout. So here the idea is to display, in fact, to render the different information related to one IP address. So here, what I'm doing, so I'm using this one, for example, and I will display, okay, so the graph information. So here I'm using Plotly. That's not the best rendering. So as you can see, even with all the function code I created, I still do not have all the information about the different nodes and so on. So that's not necessarily the best way to render. But if you go there, you will see that here we have more interesting information. So for example, from this IP address, I can say that it's contacting this specific hostname. It's trying to download this specific URL. It's using this user agent. But also use the different Docker images like BuzzyBox and Ubuntu. That's not the most interesting ones, but here we can see the chatter one, and also this one. So yeah, we can render pretty much everything directly as a DB. And here we have all the command lines which have been executed by this IP address. So then we can also display some more information as a text. So here we have the different campaigns related to this IP address, the different related URL, command lines, etc. So that's another way to render the data. And we can see also all the related IP addresses linked to the different campaigns. So for the 21 campaigns identified here, from this specific IP address, I'm able also to extract all these associated IP addresses as well. And then, so the idea here is to be able to easily pivot from an IP address to other type of IOCs. So for example, here I'm just pivoting, querying. In fact, for this IP address, I'm requesting the database all the different related IP addresses found in similar campaigns. So this is our query language at Datadog, but yeah, you can quickly have this specific information. Here we can also pivot. So from this IP address, I would like to have all the information related to Docker images found in the different campaigns as well. And you can filter out also the most common ones if needed, of course. And finally, we can do the same thing for user agent and so on. So yeah, this is our notebook. So the demo is here. So then what next? So publish this notebook because it's still work in progress and quite part of the rapid prototyping experience of Jupyter. So it will be published sooner or later. The idea is also to connect with MStickPy for sure, because there's also cool stuff to do with MStickPy. Maybe create some data apps based on all of these, Streamlit or Quarto. I still have to find what would be the best to share this type of data apps. And ultimately, maybe answer a question directly from prompt. So just create the query related to this IP address to hunt for Docker images. And it will automatically create everything for me. So that would be awesome. And finally, so the key takeaways. So Jupyter Notebooks plus Yeti equals in my opinion, hunting made easy. Of course, visualization help understanding your data and define the different hypotheses. So I wasn't able to deep dive into too much details for 15 minutes, but there's also lots of different ways to pivot from TTPs, etc. So I let you just have a look at what's possible to do with Yeti. And of course, sharing is caring. This presentation relies only on open source tools.
Thank you so much for a super interesting talk, Fred. I feel like getting that demo and seeing them going from the graph to the actual visualized map and then seeing all the processing with that, I don't know, that gave me a bunch of ideas on applications of Yeti. I feel like I've read about it a lot, but I haven't been able to like fully play with what's possible. So thank you so much for demoing that and kind of showing us what you've learned in your work for that. It's been super interesting. Thank you.
Thank you.
Yeah, I think we're unfortunately cut short for time for questions. But I think it was so worth it to hear you talk more about it and go through all of those little things, the technical things. I think I want to make sure that everyone gets their break for this conference, just to do whatever they need to do. So we have a break for the next 5 minutes. So we'll just go off, and in the next 5 minutes, we'll come back and listen to the next speaker.
Hey, everyone. Welcome back from the break. All right. Yeah. Welcome, Cohen. I think Cohen has been a freelancer in threat intelligence and IR space and been in the 20 years of experience with the overall security. I think I'm also excited about this specific talk about the MISP playbooks with the Jupyter notebooks and Python library PyMISP. So yeah, over to you, Cohen.
Okay, thank you for having me. Just let me share my screen. Can you give me a heads up that you got a view on my playbook?
Yep, looks good.
Yeah. Okay, so thank you for having me and for providing time for the presentation. I'm Koen van Ipe. I work as a freelancer in incident response threat intelligence. I've done some open source contribution. Yeah.
Sorry to interrupt you. Could you zoom in a little?
Yeah, sure.
Great. Thank you.
Is it okay? I'll put it like this. Is this okay?
Yeah, that's
so
great.
I've done some open source contributions to MISP and D4 automation tools, and I'm also the maintainer of the Austin threat feed bot 3.2. And today I'm going to talk about the MISP playbooks. Now, MISP playbooks, they address common use cases that you encounter when you're working in a SOC, CSIS, or CTI team, and specifically when you have to deal with information or intelligence that is received by MISP. The MISP playbooks, they have a couple of components. The major component to use are the Jupyter notebooks. And the Jupyter notebooks are basically the glue that link together the documentation with the commands and services that we want to use. Documentation, for example, your incident response procedures, CTI investigation guidelines, the commands, the queries that you want to execute, the services, for example, external correlation or enrichment services that you want to use. The output of the playbooks can be used for reporting purposes. It can also be used to update your MISP data set. You can also use it to send, for example, notification to Mattermost to inform your colleagues of your work, or create an alert in the Hive or any other case handling system that you're using. So next to Jupyter notebooks, another component for the MISP playbooks is obviously MISP. MISP is an open source threat intelligence and sharing platform. It's heavily used by a large number of SOC and CTI teams, and it has all the features that you would expect in a TIP. Collect data from external sources, do some normalization, enrichment, correlation, and then analysis and disseminate and share with your community. Next to MISP, the MISP playbooks use PyMISP, and PyMISP is a Python library that allows you to interact with the MISP REST API. If you use MISP as a normal user, the web interface, everything that is available there is also available through its REST API. So to make that access a little bit more easier, you can use a Python library, PyMISP. And then last element that we use for the MISP playbooks is the MISP modules. And MISP modules are a way to extend the functionality of MISP with additional features without having to change the source code of the core component. So you can look at it a little bit as plugins, extension of the source, and typically use it to import data from external sources, or you can use it to query, for example, hash lookup or VirusTotal. The MISP playbooks, they are published on GitHub, and the project started last year. And currently we have about 16 playbooks available for users and administrators. And there's also some guidance and technical documentation. Now, if I just quickly go through the playbooks that are available for the different users, there are playbooks to deal with malware investigations. For example, do malware triage with static malware analysis, dynamic malware analysis, look up hash information. And here in the overview of the playbooks, I also listed the external services that are used in all these different playbooks. So for example, the one for malware investigation uses VirusTotal, hash lookup, malware bazaar, but also VMware and hybrid analysis. There are playbooks to do OSINT investigations. For example, query for CV information, IP reputation, domain reputation, playbooks to work with phishing incidents, and then a couple of playbooks to improve your CTI work. Curate the threat events that you have in MISP, look for inconsistencies in MISP, do some threat actor profiling. And lastly, there are a couple of playbooks that help users to get more acquainted with the MISP features. For example, how to create a MISP object, how to create MISP relationships, how to work with different timestamps, and how to create a MISP boarding list. So these are the playbooks for users of the MISP platform. Also a couple of playbooks for the MISP administrators, for example, how to provision users and organizations and do some cleanup of the events that you have in your MISP environment. As I said, there's also documentation on the GitHub repository, technical documentation on how to set up your Jupyter Lab environment, guidelines on how to create notebooks, guidelines on how to use them, configuration files, for example, for setting up Jupyter Lab, configuration file for an Nginx reverse proxy, if you want to put that in front of the notebooks, a systemd script to start it up, and a step-by-step guide to install it on Kali VM or any Linux VM that you want to use. And there's also one specific skeleton playbook that is just used to start a new playbook, but already contains the different components of the structure of the MISP playbooks. Now, what do you need to get started with the MISP playbooks? Obviously, a web browser to interact with your Jupyter Notebook environment. In that notebook environment, you need to have that Python library to interact with MISP by MISP installed and any other Python libraries that you want to use. You need to have access to a MISP server. Can be your own MISP server or can be a MISP server from one of the MISP communities. You need to have a REST API key to interact with that MISP server. Then MISP modules need to be installed. And if you want to use various total URLs, but obviously you need to have an account there and more specifically the API key of that account. Already mentioned a little bit the skeleton playbook. So in an overview of the structure of the playbooks, there's always an introduction section that describes what the playbook is about, the intended audience of the playbook. Then we go to the playbook that covers the use case that you want to solve. And at the end of the playbook, the closure section, it can, for example, send out a notification to Mattermost or has a list of external resources that are used or the technical details of the playbook. Now, it's only a short presentation, so I immediately jump to a short demo. All the playbooks that I just covered that are already available, they are published on GitHub. And on GitHub, we always have two versions of the playbook. There's one clean playbook that you can copy and use immediately in your environment. And there's also always a playbook with the output of some dummy data, some OSINT data. By this way, by having also a playbook with the output available, it allows users that are not acquainted with the type of playbook or type of information, check, okay, how does this general workflow of this playbook work? What exactly has been done and what kind of output can I expect to work with? Now, the structures of the MISP playbooks, as I said, there's an introduction section with a unique UID. There's a link to a GitHub issue, because every playbook has to start from a GitHub issue where you describe what you want to do. There's purpose of the MISP playbook, some tags, the external resources that are used, and the target audience. Currently, the UID and the tags, they are not used, but they're already put there. If the MISP playbooks are integrated in other platforms, at least by having that UID and the tags, it makes it just a little bit more easier to already start using them. So first, that introduction section, then move to the playbook section, where you first have preparation and you do some initialization of the environment. So first loading the required Python libraries. Then you load the credentials to access your MISP server or any other external service. You load these credentials. In this example, you just load it from a file that exists on disk, but you can also as well just ask the user to input them in the playbook. And then lastly, we create a PyMISP object. And by doing this already at this stage, we are sure that if this PyMISP object is created and we have a valid connection to the MISP server, the playbook can execute. It doesn't really make sense to do this check at the half of the playbook and then start pushing data to MISP and then suddenly realizing that there's no connection. Just we do it at the beginning. We can immediately check that we have a connection to our MISP server. So just started here, and the output of the cell gives me the feedback that, okay, I have a valid connection to the MISP server, a demo MISP server that we can use for this playbook. Next, we set up the connection with the MISP modules. So I explained that MISP modules, they allow you to extend the features of MISP without having to change the source code. So it's an external service that provides additional features to MISP. In this case, the MISP modules, they are installed locally on the system, and we're just going to use one MISP module HashLookup service. So just starting that, and the module server responds that, okay, it's available, and the hash lookup service module accepts 3 hash types. Next, loading a couple of helper functions. Now, in the current iteration of the MISP playbooks, the goal was to make them as portable as possible, meaning that helper functions are included in all the playbooks. That's good for portability. That's not that good for code maintainability. So that means that all these helper functions, they have to be repeated in all the different playbooks. That's going to change in the future, but currently for the portability, those helper functions are still included in the playbook and not loaded from an external file. And then the next section to conclude the preparation part is setting some helper variables that we're going to use further in the playbook. Then come to the core of the MISP playbook, solving a little bit our use case. And in this case, the use case is we want to query a set of indicators in MISP. We want to know what does MISP know about these indicators. We want to get the details of a specific event, and then we want to get all the events related to one specific threat actor. In this case, I have identified 2 indicators that I want to check what does MISP know about these indicators. In the MISP playbook, in the guidance documentation, we included that the variables need to be separated from the code just to make it more easier for people who are not accustomed to developing code in Python, who don't want to fiddle with the code. By having those variables split from the code, it's easier for them. They just have to change the variables and they can still run that playbook without having to play with the Python code. So assign the indicators. And then as a next section, we can execute the search with MISP. If you do a search with MISP with PyMISP, there are a couple of options that you can provide. Obviously, the indicator that we just defined earlier. And then in a MISP search, we can define that. Do we want to have published events or only indicators with 2 IDs? Just to clarify, published events in MISP mean that you have made them available for your community. And the 2 IDs field in MISP is an indication of an indicator if it needs to be actionable, meaning do you want to do something with it, or is that indicator just there for informational purposes? Now, in this example, I just want to get everything that is known by MISP on these 2 indicators. So let the query run. We get the results back, and then I just print them out here, easy viewing in a pretty table. And I assign the result of the table to a variable, because at the end of this playbook, I also want to send the information to Mattermost and give some kind of heads up to possible colleagues. So this query is run. I got a table with a couple of events where these indicators have been seen. And it's a little bit of demo, so I'm steering it towards specific direction. So I'm mostly interested in this threat event, 3345, threat event attributed to Seedworm, Iranian threat actor. I want to get some more details about this threat event. So similar as for querying for the indicators, there's a specific cell with the event ID. I want to use the data for this event ID, and I want to get all the information that MISP has on this event ID. I'm going to query that data. First, get some metadata from the MISP event, the contextual elements that exist in MISP for this specific event, external links that provide additional information on this threat event, and then the indicators and attributes that are part of this event. And I'm going to print it out in Markdown, but still the results are also stored in a variable, because again, I want to send this out later on to Mattermost. And this gives me a good overview of the organization that created the event, the ID, the date, distribution analysis, some contextual elements, and then all the attributes that are part of this MISP threat event. Something that can be useful to work with. Now, in the next cell, and I'll scroll a little bit back. So we look at the contextual elements. This threat event is attributed to Muddy Water, and I want to get some more information from MISP on all the other events that have been attributed to Muddy Water in MISP. So again, the same approach. I'm assigning Muddy Water as one of the context filters in a separate cell, and then I'm executing again a search on MISP, but this time the search is filtered on tags and not on indicators. Again, same approach, doing a search with MISP. Now search for events, put them in a pretty table, and assign the results of the pretty table to a variable so I can use it later on. I got 3 events that all cover all attributed to Muddy Water. Now, as the last step, all these variables have been filled with results from the previous query. I can send these to Mattermost. And just for checking, if we go to Mattermost overview, this is the event that's just been sent to from our playbook to Mattermost channel, where we can, for example, inform our colleagues. Now, this is for querying MISP. One of the other key elements in the MISP playbooks is creating a MISP chat event from your playbook. And the approach is more or less similar. So we create the MISP chat event. We assign the variables outside of the code block. Then we create the MISP event. And here, in this case, I've condensed it a little bit. We create the MISP event. And in the same block, we also assign a couple of contextual elements for this MISP chat event. So we assign the TLP traffic light protocol code destination, some chat actor, some TTPs, and some local tags and some global tags. So just creating the MISP chat event. The playbook responds, okay, this new MISP chat event has been created. I'm going to add some attributes to MISP. So I have a set of indicators here, IP addresses, file hashes, file name that I want to add to MISP. First, assign the variable, and then I loop through these assigned variables. And for each of these indicators, I create an attribute in MISP with the corresponding type, comment, and for some of these variables, for some of these indicators, there's a tag that I want to add. This provides me the feedback here. Now, as you noticed, 2 of these indicators are file hashes. These MD5s, it's very difficult to know exactly which files are associated with this. And I want to avoid adding file hashes to a chat event that might lead to false positives. So one of the services that we can use for this is available through the MISP modules. It's a hash lookup service by Circle, which gives a list of known good software. You submit a file hash to it, and it will indicate if it has seen this associated with known good software. So these 2 file hashes, I'm just going to submit them to the hash lookup service. There's one file hash which corresponds with calc.exe. And by knowing that, okay, this is associated with calc.exe, it's not really a good idea to do some alerting on the presence of calc.exe. So for this attribute within MISP, I'm going to indicate that this indicator is informational purposes. I do not want to have some alerting or some detection on it. This is done by setting the toIDS field to false. Then good practice, if you create a MISP threat event, if you create a threat event in any platform, is to check, do we have any related information? So you've just added your indicator, you have your description. In MISP, you can do that with related events and feeds. So MISP has a set of built-in OSINT feeds. And after creating a MISP threat event, I'm just going to check all these attributes, these indicators that I've added to this MISP threat event. Have they been seen in any of the other events that exist in my MISP server? I got 3 events that were attributes have also been seen. And I also noticed that there's an overlap with 2 feeds, Circle OSINT feed and the ThreatFox feed. Last step is adding a MISP report. So we already created all these different variables with Markdown code. This gives a little bit of a description. MISP primarily contains all these technical indicators, which can also provide it a Markdown report, which can be useful to share with other people as a description. So just going to create this report. It's then added to our MISP event. And as a last step, we can publish the MISP event, make it available to our other users, and remove some of the workflow tags. And so just as a last example, I'll show you the MISP event that is now being created in MISP. This is the MISP event created through the playbook. We have the contextual elements, intrusion set, attack pattern, and the different attributes. The query that we did through the MISP modules with hash lookup is also present there. We have a reference to the hash here and all the other attributes that are present here. So that was, in conclusion, short overview of MISP playbooks. They are on GitHub and continuously updated. And I'll just give you suggest to try it out and see how it works.
Great, thanks, Cone. I think that was a fantastic presentation. MISP is one of those superpower technologies in the defensive space, and it's cool to see them expanded in this way by notebooks. I think everyone appreciates the ability to kind of easily add on the kind of process around it that we commonly come across in our day jobs.
Okay.
We have a very kind of like 1 minute basically for questions. So looking at the chat, there was one question from Ian about how easy is it to add additional TI providers? Say if you had your own custom internal kind of TI database that you wanted to connect in with this.
Currently, the focus is mostly on MISP as a database. So if you want to add an additional database, it would go through MISP. So ingesting the data in your MISP platform and then doing the query there. Technically, you could expand these playbooks to other platforms also, but the goal here was really to work with MISP as a central platform. So if you want to use other TI providers, I would suggest to integrate it with MISP. That would be the easiest way.
That makes a lot of sense, yeah. Well, great, thank you so much. Really interesting talk, and I think it's one that's going to be very kind of useful and practical for people to go away and implement straight away. So thank you for sharing.
Okay, thank you for having me. Bye.
So next up, our next presentation is Swarup. They are an experienced cyber defender across both kind of cloud and hybrid environments, and a lot of experience in their career. And they're going to be talking to us about a very interesting topic, which is how to apply risk scoring to atomic alerts. And again, I think anyone who's worked in a SOC environment be kind of very familiar with the alert fatigue and the kind of flood of atomic detections that come in, and understanding how to prioritize and handle those is a really difficult and interesting job. So I'm really kind of excited to hear about how we can use risk scoring to kind of make that process easier. So thank you very much for joining us, and over to you.
Thanks, Fred. Appreciate the introduction. I'm going to go ahead and share my screen. Okay, is my screen on the screen right now?
Yeah, we can see that screen.
Okay, perfect. Okay, so as Pete described, we're going to talk about for the next few minutes about just to set up the stage that the goal. I mean, we're going to go over a little bit of goal and context and objectives. Then we're going to jump right into the demo that we're going to model certain attacker activities and how to see how we can sort of prioritize or identify an evil alert from the noise, and also be able to correlate those alerts as such. So with that being said, like I said, the goal is to find a signal of malicious activity from the noise. The question is why. I mean, oftentimes the false positive and false, you need to find a balance between the false positive and false negative. If the detector or signals, when detection engineer writes those signals, right? If you try to reduce a lot of false positives, then it leads to false negative. But then if you reduce the false negative, that also tends to get to the false positive, right? And oftentimes a real attacker will often have to trigger multiple detections. But in isolation, it's isolation of a only given trigger or a signal is likely a false positive. So especially dealing with the sophisticated alerts, in the advanced attackers, they operate in very stealth mode. So what is the objective here, right? I mean, obviously we're going to implement a strategy to model certain entities and assets based on the risk and also threat. I know there have been debate about should we do risk-based approach or threat-based approach. So risk-based approach in that, what are the assets and identities we are protecting, and threat is like what are, based on the threat model of the organizations, what is the threat we are going to defend from, right? So in my opinion, we must actually incorporate both the side of the coin. Then the objective is obviously implementing detection of multiple. I mean, to be able to correlate, not just detect the noise from the signal, but be able to correlate across the state, right? I mean, how can we identify entities that actually really correlates with at given point of time, or through a period of time, how the entity was the historical risk score of that, and how we can take that into it, plot it in a timeline-based, window-based timeline, compare within the timeline to see how and what the risk has evolved from the time it has been seen for the first time to over a period of time. And obviously, the benefits are we'll be able to investigate quickly and dispose of the true positive and false positive. And of course, when you have a high fidelity detector, then obviously the response is going to be very effective, and also be able to prioritize among the noise, how to to be able to prioritize, to be able to respond to those alerts in an effective manner. Okay, so with that being said, we're going to do a demo of applying these principles that we have just spoke about. So the hypothesis here is that we're going to model attacker tradecraft behavior, where an attacker was able to, so organization is running some microservices within a KS infrastructure, and the hypothesis is that an attacker was able to exploit if the attacker was able to exploit the API server or the microservices application that is open to the outside world, then it will be able to get to the cluster, then be able to move out of the AKS cluster. Which AKS by means that it's a Kubernetes cluster hosted in Azure environment, and then it pivots off to the Azure resources depending upon the credentials it is able to get, right? So with that being said, we're going to focus on two signals right now. One is that oftentimes attackers deploy pods or containers to be able to either after the exploitation, of course, to be able to deploy some sort of stager or backdoor or reversals to be able to continue their operations to persist, as well as the next detector is that in order to be able to move from the Kubernetes cluster to the cloud environment, they would perhaps, as that pods use secrets, to be able to get those secrets. If there are any codified in that particular pod, then they would be able to leverage those credentials to be able to move laterally outside. So some questions. I mean, so we're going to start with looking for events that creates a pod or deploys a container through a Kubernetes orchestrator. So we're going to profile those events and see how we can apply scoring methodologies to those particular signals. Before we start, I think few questions we probably need to start. I like to start with. One is the data dictionary. What I mean by data dictionary is that identifying what are the sort of it's not schema. Schema just tells you the data type, but data dictionary, the way I think is that what are the sort of fields or that could be really be a identifier or be able to model with other properties and attributes. Think of this like the atomic indicators like entities besides the username and host name for the host entities perspective, and from the IOC perspective, besides the IP. Not that IP is not useful, but what other field sets and their attributes can actually influence the risk score kind of thing, right? So that means like I said, entities like observables and assets or identities, we could take any custom attributes to be able to model and apply create a framework to apply risk scoring mechanisms. Some prerequisites, some contextual informations are also helpful to decorate the alert, or that is helpful in terms of we can model those informations to be able to apply risk scoring mechanisms as well. Okay, so to begin with, I'm actually, for the context, I'm using a log analytics workspace in Azure, which has the Kubernetes logs, and we're going to look for those logs in that workspace. Okay, so here I'm using the Mystic Pi library here to be able to query those instances of the log analytics workspace. This essentially looks for the index here, and looking for the create events around here. So as you can see, that leads, and also I'm looking for a specific namespace, because usually attacker, the hypothesis, as you said, that the organization has multiple namespaces to deploy the microservices applications, but I'm specifically interested in looking for the default namespace. So that has written like about 30 events. Obviously, these are the simulated events. Like I said earlier, to focus on the identify the identifiers that could influence. So looking at this data, looks like these are the users are from the cloud provider itself. There are 30. As an analyst, I don't know where to begin with, right? So let's probably see if we could add some contextual informations to to be able to see what we could find in the later stages. Okay, so first is we're gonna start with giving a risk scoring. So I'm taking I'm just probably trying to assign a initial severity. This is based on my base judgment as such, but there is nothing. We'll see how this probably translates into more granular level, but at this time it's very coarse. So this is a function that basically looks for just echoing out the severity and the confidence level. That translates into I'm also just assigning a base score to the signal, right? So as you can see, the base score is 10 for all of the signals, and I'm also assigning a severity as medium to all of the events that return from the previous search. The next step is that, like I said, I have identified that, there are few variables that you can tune them, use as the levers to be able to apply and model them, and to see how that influences the score. So in this case, I have chosen obviously the source IP field and the container images and the container names. There are no, obviously I could do the username, but this is just running not using any cloud identities. So this is just a default username. But if we were to use I could perhaps use a username if it would have been an identity identifier that differentiates the actual users and such. So what I'm going to do is, just create take those. I'm taking container name and container image, this function, and so these are the object identifier that I really wanted to model to see how the score out of this influence the base score, right? So I'm assigning a base score of 5 to each of these fields from the log sources. I'm looking for for the privilege, then I'm bumping the score by adding by 10, and if it is so like I said earlier, that you need to, the prerequisite is that you need to be able to have some sort of inventory or watch list kind of thing. So this is for the demonstration purpose, but you could literally use any of the CMDB or attack the resource graph within the cloud providers. or perhaps an Excel sheet where to have you as a lookup table for your inventory of the known applications, known container names, and that sort, right? This is just an example of how can apply your own contextual information based on the knowledge, organizational knowledge, and the risk management practices of the organization as such. So like I said, I'm looking for the privilege specifically, and this is just codified for the demonstration purpose. But I mean, this could be used from a CMDB, and the attacker tool, I'm looking for taking the image names and looking for. I have a static list, but the way I mean it could be done is that utilizing the taxi server or modeling any tools that has like utilizing the sticks schema stuff to be able to scrape those specific attacker tools and keep them as indicators of compromise. Then utilize them to be able to annotate those specific tool sets. And the good part of this is, I mean, this is does not just specifically could be applied to this specific signal, but it could be applied. This modeling could be applied across all the signals for the AKS related or Kubernetes related signals as such, right? So what I'm trying to do right here is that this function is just emitting the risk score as a dictionary, and then what I'm doing is I'm applying the same function to the data frame that we received earlier to see if what is the initial risk score it comes with. So it's assigned, as you see, the function emitted return the results and as a risk object score, and this is being assigned to a different added as a column. We're gonna, flatten it later at the later point of time. So next, what I'm trying to do here is I'm trying to the source IP is in a sort of a list format, which was not working out for the subsequent enrichment. What I'm trying to do here is just doing some string replacement here to make it usable and passing it to the function here. I have heard, seen in the past that, attackers use to deploy tools or, containers. They don't know the baseline of the organizations. They usually, do a mistake and, sort of deploy in a different region. So this is so as an organization, you would know that, usually you have certain preferred region or, a baseline of regions. Then you can apply those contexts to context to it. So what I'm trying to do here is Microsoft publishes the Azure infrastructure related IP addresses. I'm taking IP addresses as input. This is I'm checking for if it's a private IP or not, annotating it, and also, like I said, if it's the service name is not in your region, then I'm assigning a risk score, as an on-business one. Or you could utilize those informations to apply risk scoring as well. So here I'm actually getting the output of the IP enrichment function here. Yeah, so as you say, like Azure is TUS2, and it says is private is true or false. We'll see how this information's this enrichment is useful in the next detector that we're gonna talk about, right? Okay, so I guess I missed something. Okay, so I think container image that we apply some model and risk score about looks like the risk factor column here is containing two of the events that is annotated as attacker tool here. So it looks like this image was known to be a bad image or not a allow list kind of image that is being deployed. So that's why it is getting annotated to as attacker tool. And all of the tool score for those objectives 5, but looks like this score has become 10. Remember that we assign base score as 10 as well, and there is no anomalies or rescoring for the IP enrichment, and there was no rescoring impacting this. So the way the total risk score, so I'm calculating the total risk score for the whole detector is that a base score multiplied by sum of risk object scores. In this case, the risk object score is only 10. There was no other modifier for this particular detector. Yeah, so there is another additional column here. So the total risk score becomes 50. And only for 2 of these events, the score is 100. And by the way, the score, there are 2 events. These are duplicated events. As you can see here, sometimes when you deploy a workload in Kubernetes, the pod gets deployed, but other things like a job or a demonstrate kind of workload, that also underneath it also creates a pod. So I think this event emitted because during my time of simulation, I deployed as a job as well as a pod. But in this case, I'm only looking for the pods event here. So now, between these 30 events, now we have some, by applying our risk scoring mechanisms, we are able to only narrow down to only 2 events, but sort of is actually one detector. So what I'm trying to do here is we can now, trigger alerts or filtering by those specific factors in that. I'm looking for among these 30 alerts, 30 events, which has the risk modified factor is not none, or this is not a private IP address. What are those events are? So this boils down to this specific event. So we were able to deduce from 30 events to at least having some sort of only to 1 event. So that's a huge reduction of the noise. So now, what I'm trying to do here is trying to, apply some, transforming the time generated column here, and also applying some aggregation to be able to summarize the alert. We can probably, trigger this as an alert. And so it's for now, because to be able to focus on when we can set up, we can calculate this total score threshold and give a risk threshold of 50 or 80 or 100, depending upon the how many number of alerts, and it requires a lot of iterations to come up with a actual score to begin with. But here is a summary that of 30 we were able to deduce to the only one attack, which is really which has a high risk score that requires real attention to be able to go and prioritize the triage efforts to be able to take remediation actions. Let's quick time check here. Okay. Okay, so as you said, the hypothesis is that the attackers deployed some workload to the Kubernetes and now trying to do the post-exploitation activities. So one of the post-exploitation activities we could looking for is a lateral movement activity. As you said, Kubernetes pods use secrets to be able to access resources or from the API server as well as to the cloud resources, right? So in this case, we're looking for show me what are the gate events for the secrets. As you see, it returned about 20 events, and we're going to apply the same methodologies that we went in the previous example. I'm just giving a rule name around here, just displaying the result. Oh, so this is the column. It has the rule name applies to the every column. As I said, I'm assigning a severity of medium and a base score of 10 to begin with, which is gonna later be used for the calculating the total risk score. So here, I learned from the previous one to be able to standardize the objects instead of writing a function for that text to input. So here I'm specifically modeling a risk object as user agent, and also the IP address to be able to, I felt that those are the two levers that we could tune or model to be able to influence the detector to be able to high fidelity enough. We'll see how that works, right? So I'm creating a a risk modifier or identifier object as user agent here. I'm specifically looking for the user agent that has a Python string for now, because the simulation that I did was a Python-based tool. So that was, I just wanted to highlight that one. So that is why I've been giving a risk score depending upon the outcome of this particular algorithm function. I'm just probably trying it out here and applying those this risk modeling to the whole data frame that we receive from the secrets, get secret results. So we're applying all to the all 30 base score of 10, and it looks for the user agent as a column here. Let's see. Okay, so after applying this function, it has added another column. This says risk factor, and it has two events. It says interpreter language. It looks like there are two events that was matched with this particular with these two particular events. Again, this is a duplicated event. I'm not sure why for this one, but for the pod one, I was specific. I knew that for the fact that workloads also create pod events, but essentially this is only one event, but for it to happen in a logs appeared twice. So then I'm taking the same IP address enrichment, because secrets are usually accessed by the pod, so that should be within the pod's IP address space. But if it is outside of the pods, then it's a definitely an indicator of that the secrets are being used outside of the pods. So I'm enriching the same IP address information. In this case, I'm looking for if it is not US East 2, then just annotate as non-Azure IP, non-business IP. And if the service name doesn't return anything through the enrichment of the public IP addresses, just return as a non-Azure IP. Like I said, non-Azure IP is definitely, or non-business IP are two factors that was going to influence that is really good indicators that the secrets are getting compromised and getting accessed by the outside of the cluster. So as we see that two interpreter languages, let's see the IP address. So IP address enrichment column has been added. I think I'm going to flatten it later. Okay, let's see if anything comes out here. Okay, so this after flattening, we see that this factor is two of these IP addresses non-Azure IP, and also the user agent, and also has an interpreter language is UA, and the risk object is the user agent here. So it looks like out of this out of the 20 events, we have two indicators that is indicating something going on here. So that's the event of interest of here. So I'm probably flattening it out here. The whole data frame, then applying the same filtering principles of here, that any risk modification factor for the user agent is not null, and the service name is not none, then only filter that. So we were able I'm reducing those events which is really stands out from the noise, which is the two events that we saw earlier. I'm doing the duplicate of those events around here, and also summarizing the alert that this is the specific event that is really of interest, and this has the total score of 200 out of all the no event has any score, but only these two events has the score total score of 200, which is clearly an outlier of that sort. Okay, so now what I'm going to do here is that I'm going to combine the deduced event from the pod created event, as well as the secrets being accessed, right? So we can, I mean, ideally in a production environment, we would probably, instead of setting up the alert based on the pattern match, we can reduce this to single alerts, then probably write it to a time series database. Then we could utilize the the similar pattern matching capability to be able to query those indexes. So think of these indexes is just the deduced event, which is in the being returned to a database, or in this case, it's a pandas data frame. So what I'm trying to do here is to plot the timeline and group by the source IPs, because after combining, you can see that it's the same IP addresses coming out of it, and we could model with the username as well. There are two events here. I'm going to create a timeline plot for this two series in this data frame and group by the source IP. As you can see that on 28th, the attacker has deployed a pod. Then since we have only two events, but then the 13th, there's a potential unauthorized K8 secret access with by an entity with malicious attributes. The attributes are the non-Azure IP as well as the non-user agent. Then this is actually helpful in terms of correlating different ad hoc attacks. Obviously, this timeline is too long, but we have the privilege to query the data frame depending upon the indexes, like window of 1 day, 1 week, or perhaps multiple windows, so that all of these stealth operations by the attackers can also be captured by an entities. In the next step, I'm actually querying the data frame. Excuse. For the last 20 days, give me and group by the source IP entities, and what is the total score sum. So looks like total score sum for this entity is 300. Then we can probably start alerting if it is greater than 250. Then it's calls out for investigations. And for similarly, I'm actually modeling querying the index data frame, the deduced index data frame here, to be able to see within the last 20 days. Like I said, we could have multiple windows of queries to be run on those indexes, so that to be able to detect a pattern of anomalies. So in this case, the username also has the as a total score of 300. You can look for a threshold of 100. To conclude, we were able to model the attacker tradecraft and to be able to deduce those indicators from the noise and be able to correlate across the time window to be able to tell the story that the cluster got compromised. Persistence to the lateral movement activity, we were able to track those two activities. So with that being said, thank you for the opportunity, and I hope this was helpful in terms of applying the risk scoring strategies to the mixed signals.
Great, thank you very much. That was a fantastic presentation. Personally, it's always great to see Mystic Pi included in these things, so that's very cool to see. And yeah, I really love the way that you kind of think about the kind of risk scoring in a multifaceted way. Really interesting. I think a lot of things to kind of like pull out for people to apply there.
Absolutely.
One question that kind of did come to mind that I wanted to ask is, do you think you could take this same approach that you've done with Kubernetes here and apply it to other endpoint types in the same way? For example, like if you wanted to apply it to a fleet of endpoints within your environment.
Yeah, absolutely. So one of the techniques that I have did experiment with is like checking when the prevalence score, as well as the other was the LORBIN, kind of annotating the processes malware and model them. So the process activity or the file activity with the hash, right? I mean, we could model those as we model the container images. So any process names, that you can do a lookup in a open source database like lolbin, then annotated with lolbin, then elevate the score. Not necessarily it has to be malicious, but we know that this process has to be paid attention to, right? Then if that process is calling out with C2 signal, then we could correlate together. Likewise, the prevalence score is very useful in that I have seen a binary that is being flagged by DR. But then if I look at a prevalence score across the state, there are not too many. So if it's isolated one, that means it could be probably a binary that need attention, perhaps a targeted binary malware. But then if it is like now it is very not prevalent to see like worm sort of infection that is like available in every endpoint as such, right? So those two comes to mind in terms of applying the risk scoring to those endpoint environments. And the great thing about this risk modeling by specific entities or specific attributes is that this is reusable across the data sources. So like for this, the IP enrichment that I showed you across these two detection signals, it could be applied to other cloud-related infrastructure use cases as well. Things like a function being, Azure function being deployed, or serverless applications being deployed, or VM is being deployed from another region, right? Those could be annotated with those particular, modeling of that risk scoring modeling of that particular object. Likewise, the user agent, so it could apply to multiple data sources as well.
Great. Yeah, I think there's probably quite a few people out there who are looking and thinking about how they can apply this to their environments when they get back to work. So, thank you very much for sharing.
Oh, of course.
So next up, we are moving into a short break. So we will see everyone back here in about 5 minutes' time. So you've got a bit of time to go get yourself a coffee or another drink, depending on what time of day it is, wherever you are.
Next up, we have Riza Rashidi.
Yes.
Riza works in software security and red teaming at Hades. Today, he will shine some light on recognizing lower severity vulnerabilities by simulating attacks that exploit these vulnerabilities. Lower and mid-severity vulnerabilities often get overlooked, but they can be chained together to create critical attacks. So it's important that we give them the attention required to maintain robust security. Take it away, Riza.
Yes, thank you. Thanks for having me. I'm glad to see you. Do you have my voice?
We have your voice. We don't have any presentation.
Thank you. So sorry. Thank you. So, thanks for having me in this session. This is Reza. My presentation about enable vulnerabilities with audit vulnerabilities. As you know, today's many organizations struggle with vulnerabilities that with various security severity, like lower security severity, and also APT groups and APT and red team operator uses lower security rating that use in exploitation and also chain of attacks. My presentation about one of our security research in Hades cyber security group is CV 2030 that's related to the manage engine AD audit plus service, and that we found it and reported to the manage engine. Let's try to some example for how we can find any vulnerability with lower security severity and exploit them in organization. Let's get started. First application that include web apps and modules include of many applications and exactly modules per application. For example, as you can see, we have 5 applications that include mobile bank, internet bank, switch, core banking, and services, and also what exactly modules that's related to the application. For example, in the services applications, we have a 5 module that's related to the services application. And also we can use fetch exactly modules that use applications exactly use this, and also attackers could be exploit them with various vulnerability. For example, as you can see, services applications uses various library and class name, function name in Java. For example, access guard and out guard in the authentication module, and also OS command executor in the file browser feature and anything like this. And also we can fetch any vulnerability that's related to the applications module. For example, let's try to run it. As you can see, we have a vulnerability that's related to the access control, for example, brute force, and also session fixation vulnerability that's related to the authentication and anything like this. And exactly a vulnerability that we've found it in the AD audit is the directory traversal and insecure file upload, both of important vulnerability that found in the file upload features. And also we can make a heat map for that. As you can see, most of the founded vulnerability and discovered vulnerability, it is the lower severity security rating, and also attackers could be exploit them with various scenarios. In the next stuff, we try to make a simulation of how attackers could be exploit exactly vulnerability with lower security severity with the specific techniques. For example, as you can see, in the brute force vulnerability, attackers could be use various techniques, for example, T1110 brute force techniques in the MITRE tactical technique, and also forced authentication that related to the brute force vulnerability. And also in the authentication module could be used session fixation vulnerability, and also gather any information from deep web and dark web, and also use session fixation vulnerability to exploit them. And also other techniques and tactics that related to the exactly vulnerability in applications. And also we can use this script to exactly techniques that related to the vulnerability. For example, in the access control modules, both of the important techniques that attackers use this, for example, forced authentication and brute force authentication. And also in the authentication module, attackers use browser session hijacking, and also still web session cookie, and also remote service session hijacking, and anything like that we use exploit them. And also input-output vulnerability, for example, command and script interpreter, and also remote service session hijacking, and any exactly techniques and techniques that related to the input-output vulnerabilities. And also important thing in this CV, for example, exactly vulnerability in the import and export functionality in the AD Audit Managed Service. And also we can use various techniques, more than 20 techniques that useful for exploit any vulnerability in the import and export functionality vulnerability. And also we can use other techniques to use any vulnerability when the attackers exploit them. So far, DevSecOps maturity model is important thing today, because most of organizations use DevSecOps environment, tools, technology, people, process. And also one of the greatest book related to the DevSecOps maturity model is written by Vandana, greatest Vandana. And Vandana say about DevSecOps maturity model in level 1, many organizations use security practice and process initiation, and also risk awareness, and absolutely automation more and more, anything in DevSecOps environment. And also in level 2, we try to regular training and proactive security, anything in the DevOps environment. And also in level 3, we try to enhance training and advance automate anything in the DevSecOps environment. In level 4, we try to make an KPIs for vulnerability count by severity in the organization, lower vulnerability related to technique counts, and also time to pound counts. For example, in this thing, we try to make an script to access control vulnerability by modules, and also input-output vulnerability in the module. And all of the modules that's related to any techniques and vulnerability that be useful to attackers, exploit them in the production stage and testing stage. Also, one of the case study in my presentation related to manage engine AD audit with this CVID. As you can see, we can use this notebook to find exactly vulnerable class name and vulnerable library name to find them. And also we can use what exactly vulnerability exploitation and also techniques to exploit them. For example, in this scenario, we can fetch all of the AD Audit modules, and when I found folder 3 modules, we can insert payload like this with URL encode and also directed traversal payload. And after that, we can send requests and fetch any information in OS environment path and anything like this. And also we can arbitrary create file and folder when we fetched any OS file. For example, in the second screenshot related to the create a folder in a specific path. And as you can see, we can make a folder in C program files with archive index 1. And another case related to the paper cut, one of the greatest tools in the DevSecOps environment. And as you can see, we can fetch exactly vulnerability in the paper cut with modules, and also pop up a CMD and command prompt when the paper cut synchronize features enable. And also we can use all of the things in notebook to find vulnerability when we use network tools and also SAC tools like CodeQL and SameGrep, and also exploit them with various techniques in MITRE, tactical techniques, and anything like this. Yes, that's it. Thank you.
Thank you. It was really great to see how we can better approach some of these vulnerabilities that just don't get the amount of attention that they are always that they're always due.
Yes.
So right now we have a bit of time for questions. If anybody has questions, feel free to put them in the Discord. So I don't think that we have any questions for this so far, but I will ask a question for you. Are there any vulnerabilities that you think that you have yet to explore that you would like to look at next?
For sure, yes. We have a lot of vulnerability, interesting vulnerability like XSS with lower severity security issue. Also, we can use brute force and also directly traversal vulnerability when we use in the APT group and also red team operation. And also, we can use a lot of the vulnerability like this in the various tactic and take risks like MITRE attack, and also exploit any vulnerability and exfiltrate any information from organization. And yes, also we can integrate some of tools in the SSD stage, for example CodeQL and SameGrep, and also Bearprint DSD tools with the notebooks, and also find exactly vulnerable modules and exactly technique and tactics to exploit any vulnerability in the production.
Oh, awesome, thank you.
You're welcome.
So we can move on to our next speaker. Our next speaker that I have the pleasure to introduce is Christian Camilo Yerkaqui Lopez. Christian is a cybersecurity data scientist, assessor in responsible AI, university lecturer, and also the author of 3 cybersecurity books. Today, he will talk about his most recent book, which is titled Cybersecurity Data, the Seed of Chaos, where he shares 5 open source projects that cover topics such as prompt hacking and adversarial machine learning models for ransomware. Christian, the stage is yours. I think that we're not getting your audio.
Now, could you hear me?
Yeah.
Okay, perfect. Okay, so thank you so much for giving me the opportunity to present our latest findings in cybersecurity, artificial intelligence, for the introduction. I am senior data scientist, and there is a brief of my history. Basically, I have 10 years in the field doing some research in the academia and the industry, and I've been trying to resume some of these 10 years in 3 open source books that are available and it's free. So the resources that I am going to show you are in some QR codes. So using them, you can get some of the resources that I am going to show you. And basically, more than the 14 cybersecurity and artificial intelligence projects that I did were in using Python, and well, another one is R. But basically, we use Jupyter notebooks in order to, for example, to do the different experiments, to, for example, to create, train, and test the different machine learning models that we explored at that time. The first book that was published in 2018, and it introduced the basic concepts about the artificial intelligence and cybersecurity. Basically, if you don't know about how to use both areas for any purpose, so it is a basic book that can give you, for example, the concept, for example, to create a machine learning classifiers to detect cyber threats. For that time, the book we explored, the use of machine learning in order to, for example, to detect Android malware at that time and malicious websites. So this is a good book for if you want to begin in the field. And the second one, it includes more information about advanced artificial intelligence techniques, specifically in two approximations, in defensive and offensive approximations. So in the defensive approach, we explore other cyber threats. For example, how to create machine learning models to detect deep fakes, cryptojacking, botnets, among others. And in the offensive approach, if you don't know about it, about how to use artificial intelligence or how to use cybersecurity in artificial intelligence, we introduce, or the book introduces the concept about adversarial machine learning. We explore some experiments in order to create other offensive artificial intelligence models that could hack other defensive artificial intelligence models using basically reinforcement learning. That is a good book in order to understand the other approximations. Some of the resources that I have been trying to show you were presented in different cybersecurity conferences around Latin America that are well recognized. For example, Dragon Heart and Eco Party that is from Argentina. But you can find here more technical explanation about each of the experiment that we did. Thanks to cybersecurity companies that are in Colombia that gave us an award the last year, we published our latest cybersecurity book that includes 5 chapters, and one of them is about generative artificial intelligence, specifically the use of, large language models. And this is the kind of models that you can find, for example, in ChatGPT. So the first chapter of our third book includes the information about how to, for example, to create good prompts and the different vulnerabilities that you can find using this kind of large language models. For example, the hallucinations or something like that. And we did a specific experiment at that time using a prompt injection. Basically, we found an example from Jailbreak Chat, and the idea was to hack ChatGPT. So we did a specific experiment at that time, and it is very well explained in the first chapter of the third book. But basically, we wanted to introduce something that, for example, in this case, the idea was ChatGPT that gave us the code for a ransomware. So using one example from this prompt injection, ChatGPT gave us the code in Python that, well, it is not very well done. Sorry. The second chapter is more oriented to explore, or was more oriented to explore the use of artificial intelligence in order to provide real-time recommendations for any programmer. Specifically, we did a plugin in VS Code that gives recommendations for a programmer that have been doing his or her TypeScript code. For example, let's see in this GIF, you can see that in real time when someone is coding, he can get or she can get information. For example, in real time, if you have a cross-site scripting, or you can have SQL injection. So the idea was to reduce the time for any vulnerability in before doing any deployment or before doing a pull request. The third chapter of this book explore the use of adversarial machine learning in a set of ransomware examples that we explored at that time. Basically, we implemented dynamic analysis. We using adversarial machine learning, specifically deep reinforcement learning. We made some perturbations in the data from the network from this ransomware, and it allowed us to hack different sets of machine learning models that were proposed to detect ransomware from other researchers. And the last chapter is about one chatbot that we developed. The idea was to give any person to orchestrate a set of open source intelligence tools using natural language. Let's suppose that any person can. Let's suppose that one person wants to get information about the metadata of one image, or want to get information about a specific company or a specific person. So using natural language and the chatbot, the idea was to orchestrate a set of open source intelligence. One of them, as you can see, is the use of, for example, or get information about the vulnerabilities that are available open source. Now we are working in something like this, but using voice. The idea was to connect the voice and the text in order to do something like a Jarvis from Iron Man. So it's like a Jarvis for cybersecurity. So that is something that we are working right now. And this is a brief of the things that we have done, specifically in Colombia, in Latin America. Some of the books are in Spanish, I know, and we are working in something to translate it in English. But it's something that we are going to publish in the next, I hope, in the next few months. And that's it. Thank you so much for giving me the opportunity to present you some of the things that you can do using artificial intelligence. All of these things have done using Jupyter notebooks and Python. And yeah, if you want to connect, or you have any question, please don't do to write me or to connect. We are really open to work in any open source project related to cybersecurity or artificial intelligence. Thank you so much.
Thank you. It's great to see so much information for open source tools, and those make it much more accessible for everybody, and really interesting in this new area for of LLMs. I think that there's definitely, it sounds like there's interest in the Discord for the English versions of those books when they come out.
Yeah.
And we have a question from Cyber War Dog, who asks, what LLM models are you using for the Jarvis?
That is a good question. That was something difficult, because you know that we wanted to find an open source model. So basically, we found one that is in Hugging Face. Its name is SecureBERT. SecureBERT is a cybersecurity open source. It is not an it is not a large language model. It's something for tags. But we use this model. We use the embeddings from this model in order to adapt them for our classifier model. But it is something you can find, and I found other projects in cybersecurity. It is something that we are working on, but the name is SecureBERT specifically.
SecureBERT. Okay, awesome. Thank you.
Thank you.
You mentioned using voice to text. Are there different, or do you see potential for there being different potential vulnerabilities or attacks when voice to text is used, on addition to what already the vulnerabilities and attacks that already exist?
Yeah. Well, these are two things. Specifically, 2 years ago, we explored the detection of deep fakes in audio. That was something we used using specifically the information from the spectrum, the signals, and other artificial intelligence models in order to detect these things. That was a work that was presented in Eco Party in 2020, a great conference in Argentina. And the second one, it is for these chatbots. We wanted to create another dimension. My hypothesis is we can connect other dimensions like a voice, something like we can feel, that can transform not only the text, but yes to feel more about the computer. So I think that is the future. For me, is the future. How we can connect the metaverse, the edge computing, in order to translate them in different things in cybersecurity. So my first approximation is how we can use the voice in order to translate them in text, and basically how can orchestrate different things in cybersecurity. That is the thing that we have been trying to do in the web right now.
Very interesting. We have another question from Cyber Shadow Sociologist, who asks, have you started looking at Sora at all?
Not yet, but it is a good recommendation. I will take it. Thank you. I may try.
And then we also have a question from Ian asking, where do you see the boundaries between traditional ML and Gen AI/LLM? Do you think that the latter will displace traditional ML techniques, or maybe just have LLMs using traditional ML/deep learning as tools?
That is a good question, because currently in my current role, we have all the project that I have right now is related about Gen AI. But I think that it is not going to replace them. It's something that I think it is something that we have right now. It is something that is in the field, in the innovate. I think that maybe in the next months, like any other artificial intelligence areas, you have something that is grow up and something they down, but it's like something you have until innovate another time not something that happens. But I think that it is going to these projects are going to return. I suppose. Unfortunately, I am not working right now in traditional or predict artificial intelligence, but I suppose in the next few weeks I am going to return.
We also have another question from Cyber War Dog, who asks, from a notebook's perspective, when working with LLM-based chatbots, do you prefer to do it directly for notebooks or use tools like Streamlit to have more ChatGPT-like experience?
That is a good question. In my case, I would like to be honest. In my day-to-day, I usually use notebooks in order to make experiments, in order to understand the data, in order to make quick representations about training of the models. Streamlit for me is, or these kinds of frameworks, for me is something that you can use in order to develop quick proof of concepts in order to show to the business a use case or different use cases. But if you wanted to how do you say this, to deploy the LLM or to use more the infrastructure that you have, you need to transform in Python scripts. It is my humble opinion. So do you need to transfer these Python scripts in a formal library, something like that? So in my case, I only use the notebooks only for experiments and to do some real quick experiments. In other cases, the other frameworks.
Okay, awesome. Thank you. And I'll just ask you one more question.
Sure.
Do you see for yourself any new books in the future? And if so, what topics would you be writing on next?
Wow, it's some spoilers. Currently I'm working in the voice chat. There is something that I wrote in the chat. Yeah, I have been trying to explore the use of music, Gen AI, and cybersecurity. My opinion is you can create different artificial intelligence or different artificial things using music. So, but the connection about cybersecurity for me is social engineering. So, how we can use, for example, using, let's suppose you are hearing something that you like. So, let's suppose the music, how do you say this, when you are listening to music, you can imagine, for example, an environment. I don't know, the country that you wanted to go. So let's suppose that using Gen AI, you can create it, you can visualize it. I don't know what happens if we can introduce it at social engineering in order to manipulate the person. I don't know. That is the main topic that I have been trying to understand more to conceive it. But there's a thing that I'm going to work this year.
Yeah, that's super interesting. The idea of using music for social engineering is really fascinating. Thank you for your time. I think that we will be going to a 15-minute break.
Yep.
Thank you so much.
I was just going to say that's cool. Christian, I'm very interested in music as well, so I'd love to hear it. Cool.
Thank you so much. Thank you so much for giving me the opportunity to talk with you.
Okay, thanks everyone. We'll resume back at our old time at 2:45 Eastern time, or that would be 11:45 Pacific time. So about 15-20 minutes. Okay, see you all on the other side. Welcome back, everyone. Oddly, my camera is just frozen on an old without me, but I am actually sitting in the chair. How very strange. So I'd like to welcome John McIntosh as our speaker, final speaker before the panel. John is an independent researcher and is going to be talking about predicting Windows binary downloads with notebooks. I'll try and get my live camera back, but in the meantime, you can see my Barney and some of my musical equipment to entertain you. Hey, John, thanks very much for joining us. I hope actually we have a kind of speaker panel, random chosen. Maybe if you have time, you can hang around for that immediately after this session as well. That'd be great.
Yeah, I might be. Or is my sound okay? Am I sounding good?
Yep. Sound great.
Great.
Let me add you and remove my empty chair.
Okay, I got my presentation there. So, am I okay to go? I'll go ahead.
Good.
All right. Hi, everyone. I'm John McIntosh. I am a security researcher, and I'm coming to you today with a presentation called WinBindex Oracle. And I'll try to explain that title throughout the presentation. But essentially, I've built like a notebook to predict Windows binary download links. And as a security researcher, that's useful for me to be able to access kind of an arbitrary binary to go download and to look at. And I'll walk through that here today with you all. So to get started, I did say I'm a security researcher. I'm now working at ClearSec Labs. I like to every once in a while join Infosec Jupyterthon and pretend I'm a data scientist, but I'm not really. And we'll see that play out here in the presentation. The overview for the talk is I'm going to teach you guys about WinBindex. If you don't know about it, it's an open source index of download links, essentially, for Microsoft files. I'm going to teach you guys how to generate those links yourself. And then I'm going to walk you through an observation I had when I was looking at some of these, I call them Microsoft Update Manifest files, and how I might be able to predict download links using a little bit of pretend data science that I just talked about. So, and I'll also show you how to build an oracle from that. So to get started, we'll talk about WinBindex and introduce what that is. And so this has been around, I think, maybe 3 or 4 years now. And it's an open source resource by Michael Maltsev, who's, this is his blog post about it. And it's really just him solving a problem that he had, downloading some files that he needed. And I'll talk to you about how he's done that. In the end, the output kind of looks like this. It allows you to type in like an arbitrary Windows OS binary and go and download that directly from the Microsoft servers that they're serving and hosting on their public symbol servers. This is useful for me when I do something called patch diffing. When I compare two binaries, I need to get two versions. I can go and easily download those. It'd be easy if you wanted to debug a software or service and you needed the file itself to run. Useful for all of those things. But his main points for building this whole index was that he needed to get a collection of drivers, but there was no way to go and download those individual drivers without downloading these huge ISOs or update packages. And so he wanted to solve that problem. And so he looked into it, into what he needed to do. He found the update packages were too big, as I mentioned, and he wanted to download individual files, but and he also had this information knowing that the Microsoft symbol servers host both the symbol files for a binary and also the actual file itself. So leveraging all that information, he went and said, oh, maybe I can download the binary directly from the public symbol server if I had all the information. What he found, as I said before, the symbol server hosts both the PE files and the symbol files. And with that, and knowing how to construct the URL, which we'll get into more later, he kind of built a way to go from the hash of a binary all the way to a Microsoft download link. And so his process kind of looks like, for generating his large index, is to start with this Microsoft Update Package Manifest file, which gives you a list of all the files within a specific update. And from there, you can kind of go down and see this, like the SHA-256. He can pull out the SHA-256, and from that, he can get the information he needs to build a Microsoft download link. Visually, that looks like this. From a Microsoft Update package to a SHA-256, he actually leverages a VirusTotal, looking up the SHA hash and getting the information about the file that's needed to build the download link, which is pretty insightful on his part to go and do that. Now, he's got a big GitHub repo that does all of this and automates it and kind of builds that index automatically. He's been doing that for the past several years, but this is like the big picture that he's using. And what I'm trying to do is explain what WinBindex is and how WinBindex works today. As I said before, he leverages VirusTotal. It might be hard to see this picture, but there's some information you can pull out from the PE file that will allow you to build a correct download link to go and pull that binary from the Microsoft symbol server. And so, real high level, WinBindex is really useful for security research or for downloading individual files. In this whole presentation, I'm going to show you how I used Jupyter notebooks to take a slightly different approach to do the same thing, and we'll see in the end how it's worked out for me. So here we go. Let's start by talking about this problem, and it's not a real problem, but it's a problem for me. How do I generate these Microsoft binary download links? And there's a blog post out there that kind of describes how to do this. And the three things you need to build a download URL from the PE file itself are something called its timestamp, its file size, and the name of the file. If you have the PE file, if you have a copy of it, you can actually build the download link and pull down the symbols and file as needed. But we're talking about the case where you don't. So here's a quick algorithm that shows you, how could you build this actual URL if you had all these values. And we can actually go and practice that. Like, we can actually go and download one of the binaries, put it to disk, and then pull out those values and regenerate a valid download URL from the Microsoft symbol server. And that's what I've shown you here. An example of, like, you can pull out the timestamp, you can pull out the virtual size just by reading the PE file on disk and extracting data from certain parts of the PE file. And so at the bottom there, we have this download URL, and that's a legitimate one, and it matches. So we verified we can generate download links. We know how to do that, and WinBindex is doing that on a large scale. But there's something I noticed when I was looking through the Microsoft knowledge base, like security update manifest files. They kind of look like this. For every time a new update comes out, Microsoft will publish information about the update. They even, at the bottom, they include a link to a CSV file that says, here's a list of all the files that have been updated, and use this as you will. And when I looked at it, and I looked at all the columns, information inside of it, what I kind of saw right away was, hey, do we have all the information that we need from the CSV file to build a download link? And I thought, oh, maybe we do. And so I tried it out. I tried it out with a notebook here. I said, okay, let's try one file. Here's NTDLL. Here's its file size. Here's its build time. Can I make this work? I don't need to download the update, pull out the manifest file, and query virus total, because I have all the information I need right here. Is what I thought, and we'll get into that. And so I tried it. I pulled in information from that row. I built a download URL, and I tried it. And the first time coming through, the URL did not work. It was not a valid link, and that just proves to me that I don't quite have all the information that I need. So I had to dig in a little bit further. If I look at the timestamp that was given to me from the manifest file that from the KB knowledge update, the timestamp actually doesn't provide any seconds. The seconds are 0. Without seconds, I don't have the complete build time, and none of the files listed actually include the seconds for the build time. That's a problem, but something that can be probably overcome. What about the image size? From WinBindex, in his blog post, he describes kind of how to generate this virtual file size that he's trying that's required to build a valid download link. Well, he's pulling this information from specific sections, from information from virus total, and I don't have that information. I just have the file size and timestamp provided from the KB update. And so what I'm trying to say through all that background is that the KB update file that I found, I thought might have all the information, provides almost enough information. And what we need to do, what we're going to attempt to do, is build an oracle with incomplete information. So how can we predict the download links using partial information? And so here we go. And this is the journey of doing that, leveraging Jupyter Notebooks to do it. And so I've kind of invented a problem, but we're going to solve it with Jupyter Notebooks, and we'll see how useful it is. So the goal is to start with this partial information, predict the correct download link. What we're missing is the correct build time and the virtual size that needs to be accurate. And let's see, how can we build some potentially valid URLs? Well, first we're going to start with a notebook, and we're going to read in that CSV file. It's kind of messy at first. We're going to clean it up a little bit and make sure we have the file name, the versions, the file size. Oops. And all of that information available. To get to the seconds, that's not too hard of a problem. If we take, this is a URL, this is a valid URL. You can click on that and it'll download the file. If you break that up into its parts, you got the server, the file name, the timestamp, and the size. can we take the information from the KB manifest CSV and actually build a valid URL and build it with a correct timestamp? So if we parse out that information from the CSV, what I noticed, again, like I said before, my timestamp does not have any seconds, and the valid timestamp actually does. It has, is 21 seconds. So that's not too hard of a problem because we can just iterate through and go through all 60 until we actually find a match. And so that solves the problem for the timestamp. It also implies that for a single file, we're going to have to make up to 60 requests to find the legitimate number of seconds. And then the file size, the same type of problem where we go through and we say, oh, the file size given to us from the manifest file that I found is hex C00. That doesn't match the URL. We need to actually make that match. We need to make sure it's page aligned. We can use this function to do that. It just aligns the size on a 1 kilobyte boundary. And then we can kind of do a similar thing where we know the valid size is 1100 from that URL, and we can kind of iterate through until we find one that works. And so in this case, I think I'm looking through 15 different possible sizes that it might be. And from there, we can actually go through and generate all the possible URLs that it might be using our parcel information. Now, if we look at the numbers for this, each file, if I use this algorithm that I have right now, it's going to take up to 960 requests to find a valid URL. And that's not really that practical. But this is what it would look like if I'm building a bank of potential URLs. I would put them in here. I would try all the 0 seconds, and I would try all the different sizes that I would need and kind of iterate through there. And in the end, if we do some math, if you were to do a full KB manifest file, and that's 960 requests per file, we'd have to make quite a few requests out to a server just to get a download link, and it's probably not worth it for the entire KB thing. But if you're just going to try for one, maybe that would be worth it. But so leveraging notebooks, leveraging a little bit of partial information, we can build a valid download link. What I'll try to do is switch over to, let's see if I can do this. Do I just add a new? I'm going to switch over to a demo. We're going to try it in real time. And we'll just try it for like 25 files and see what we get. So present. Is that coming through? Oh, Ian, I might need, yeah, thank you. Great. Okay, we're gonna go through here. This is me trying a couple different ones. We're gonna try the one from my demo here. Just writing this data. We take a look at the file. Again, it needs to be cleaned up a little bit. Wait, I'm trying to get this bigger so you guys can see, sorry. Hopefully that's better. All right, so we've ingested the CSV file. We've got it into a data frame, making this useful. We need to clean up the data a little bit. And this is just me pulling out some valid files. And so it's a little bit more usable. We got the dates, the times, the file sizes, everything we need per file. We're going to take this big long list that's about 5,000 files for this 1 KB. And we'll limit it down to just 25. And we'll take a look at the first 25, and we'll see what we can do leveraging our algorithm by predicting the seconds, predicting the file size. We're going to thread this. We're going to not make it an actual request for the file. We're just going to do a head request. So we're just going to verify the URL and not pull down the content. So we'll not waste anything there. And we'll go through and try this out. And I'm not going to walk through this whole algorithm, but I'll just show you it running. And so this is running in real time. And so for the files that it can't find any actual data for, it's going to, it's going to go through all 960 requests and not find anything. I don't think it takes this long normally, but of course for the demo, I'll just let it run long enough so that we have some results. And so what I'm showing, and these are actually failure cases because they're not finding the URL. They're going through all 960 requests. And it should be running faster, but I'm not sure what's happening right now. Let it find one, and then I'll maybe switch over to the normal. Come on. Yeah. Oh, okay. Didn't mean to do a trick there, but okay. So I did find both of these files here. This Bluetooth print.sys. It took it 526 iterations instead of the full 960 for this one. As it has success, it'll take, it just print out the result of how long it would take. And I'm not going to let that finish just for time's sake. I have a copy of it just down below. But what I do have is kind of the results down here of, for the 25, which ones did have URLs that it found. And so what I was able to prove, at least for some of these, is that I was able to brute force and find. Now, what I would have expected actually was I would be able to find all of them, and I wasn't. So let's dig into why that is the case. If I come back here and I stop sharing that screen, I'll switch back to my presentation. Okay, are we back live here? Yeah, it looks good. Okay. In all of that, making it work, seeing the verification of the files coming back, we're able to predict some lengths, but not all. And that actually comes down to this fact. And even Michael actually alludes to this in his blog post. He says, for some of the timestamps, they seem a little bit crazy. The timestamp for the binary he was looking at was 2096, and that does not seem right. It's in the future. And there was a reason for that. It said, starting with Windows 10, the timestamps of the PE files are actually file hashes. And this has to do more with making builds reproducible. So because they were using valid timestamps prior, and if they rebuilt it, but no source code was changed, it would seem like the file was updated or whichever. So they stopped using the actual timestamps and they started hashing the file, the contents of the file, to actually instead of using the timestamp. So the timestamp now for Windows 10 binaries actually is not a timestamp at all, and it's a file hash. And so that is why it works for some of my examples and not others, because I think they were in the middle of changing all of that to use actual file hashes instead. So all that to say is, I had this idea of maybe I could use these KB CSVs and shorten this URL prediction process a little bit. And it does work for those that actually use real timestamps. But for all the new files that are now published, like the most recent updates, my Oracle does not work at all. And so it's not so impressive, but it still shows you an example of how you can use notebooks to kind of prove out your theory, or kind of iterate on some of the data and see what works out and what doesn't. So that was a long-winded way to make up a problem and solve it temporarily. But I do want to say notebooks is still working for me for wherever I have data that fits into a data table, and I can iterate on that, start to ask questions, start to use graphs or whichever to kind of visualize that data. It's been helpful, and I used it for WinBindex to create this Oracle. I suggest if you have a similar problem, no matter what your field, if you're doing Infosec or DFIR or whichever, in my case, security research, Jupyter Notebooks could be powerful for you as well in the same vein. So it's a little bit short. It's all I have. I don't know if there's any questions, but yeah, this is my WinBindex Oracle. Used to work. It was a fun experiment anyway for me to go through.
Hey, thanks very much, John. That was Yeah, I kind of use notebooks in a very similar way myself. I haven't got a question, but I often use it. Like I write a fair amount of code, and often write the initial code in notebooks because it's so easy to get the immediate kind of responses and then transfer it to Python files. Or yeah, it's a kind of great general purpose platform. The question I had, maybe an obvious one, is like downloading the files. What do you then do with them? Are you kind of like binary diffs, kind of reverse engineering to see what the security fixes were?
Yeah. So I use Apache Shipping is definitely a hobby of mine. I have some open source tooling that kind of leverages kind of automated patch shipping on the command line, and it's really useful for me to have a source of binaries to go and reach from. So if I want to say, yesterday or last Tuesday was Patch Tuesday, all the updates came out from Microsoft. If I wanted to see the files that have been changed and focus on and for me, I'm looking to see, focus on the security related changes. And so patch shipping is a great way to do that. I leverage WinBindex quite a bit to download the files to get the new file update. So I don't have to download a whole ISO or build a new version of Windows. I can actually just go and look at individual files themselves, download them individually, and not download gigs and gigs of data to go and look at those things. And so that's kind of my use case for it. And yeah, and so this was my WinBindex Oracle was a way to maybe I can find an easy way to do this. And the answer is you could use the Oracle if the timestamps were correct, but they're not anymore. So,
is there? I can't think of a way that you could, obviously guessing hashes is a little bit of a tricky, tricky proposition that probably lots of people would be interested in knowing how you could do that.
The downloading the links or the
hash? You can obviously iterate through missing timestamps, but you can't obviously iterate through missing hashes of a file quite so easily.
Well, yeah, and now they're not using timestamps. The hashes, the information I have is no longer relevant. So now it becomes from me iterating over 15 different possible file sizes to build this timestamp. Or to build, I can't do it. I can't produce the hash without having the file, essentially.
Yeah.
So, anyway.
Yeah. Cool. Well, thank you very much. Let me just check. I can't see any other questions. We're going to kind of switch to. We're not quite sure how long the final panel is going to go, but we're going to invite a few people who are still have the stamina to hang around. If you want to join us, and we're just going to kind of mess around with some questions around notebooks and Gen AI specific stuff.
Yeah, I'm happy to hang out for a while. I will have to leave here in a few minutes to go. But yes, I'll hang around as long as I can.
Cool. Okay. Well, let's get some other people onto the screen. I'm only putting people on who've got their cameras, so other people who are not visible.
Hey, John, just a quick question. Meanwhile, we add more people. So when it comes to using Jupyter Notebooks, I saw one of your projects, Ghidra Diff, right? I think it's called like that, Ghidra Diff, or
yeah.
Ghidra Diff, right? Okay, yeah. So do you use also notebooks with that? Ghidra binary diffing engine, yeah, Ghidriff. Okay. Do you use that also with Jupyter Notebooks? Because I see that it has some Python commands, I guess, or like Python modules that you can use with some parameters. So I wasn't sure if you also use it with notebooks altogether.
I use the notebooks on the side of kind of the analysis of maybe like looking at CV information to say, which binaries are actually related to a specific like CVE or something like that. Now, Ghidriff is it's Python that's leveraging Ghidra to do all of the binary analysis and then iterating the files just to find all the differences. And so I did a couple of talks last year presenting that tool and released it open source, but I don't use notebooks for the diffing aspect, but I use it for the research side of, okay, I have a bunch of this data or a bunch of these files. which ones are important, how do they relate in that way. So.
Nice. And I also saw that you have a lot of mermaid visualizations of how the functions connect to each other and all this stuff. And I remember I was doing some research before with RPC functions connecting to other functions, and then it seems that what Leo's team actually created recently to explore data frame graphs in a data frame version. It's like another step, right, to this whole research area. So I love to see notebooks being implemented in like multiple areas of research and not just like one thing, right? So
that's what led me down this path. Actually, that original project that you had that was doing that like large scale analysis of the Windows files and how
nice.
Yeah. So that was cool. Yeah.
That's amazing. I'd love to hear that. That's awesome.
Yeah.
All right.
Yeah.
Cool.
By the way, it's nice to meet you, John, face to face. I know we've had some conversations on kind of online forums and stuff like that. But like, cool.
All right. Ian, you want to get started?
Yeah. So I kind of made up some questions. We're still open for other people's topics, but there were a couple of like Gen AI things, and one thing about productionizing notebooks. So there are a couple of people talked on, like Ryan yesterday gave a keynote on the amazing stuff that they've done in SecureWorks about creating a kind of production pipeline based on notebooks. But I'm kind of wondering, like, what do people think? We've been talking about this for a while. Like Netflix also created this production pipeline of all their data analysis based on notebooks. I know other people have tried it, but do we think that's a destination for notebooks, or do we think that it will typically just always be a kind of experimental, mostly individual analysts using them for, well, like in my case, sample writing code, like analyzing data. Anybody want to? Is the question clear?
For example, in my case, one project that we had a few months ago, we usually use notebooks in order to, in Databricks specifically, in order to orchestrate some ETLs and so in a pipeline. But specifically, it was for using all the infrastructure in Databricks and Microsoft Azure at that time. But that was something in production system for only systematically execute some steps. That is one experience that I have.
Yeah, so coming from our side, and we've kind of already made sort of our bet on it in Louis, like that. Like we basically, my sense is the Jupyter approach of kind of duct tape of a lot of not exactly working well together pieces is just not very smooth. So it's like maybe one day there'll be enough pieces together that it's productive for a team. But today it becomes very janky to get GitHub working, like get Git working with it, and then get stripping of stuff, and then whatever your orchestrator, that there is just like a lot of integration annoyance, and so it just comes out very janky. But I think Christian's point about Databricks is we kind of came to the same conclusion with Louis, where it's like if you have a platform where you have notebooks, dashboards, orchestration, APIs, all kind of pre-integrated, that becomes a lot more practical for teams. If not, like the duct tape is, I don't want to be the one responsible for maintaining that. Throw in Kubernetes into the mix, and now all of a sudden it's painful. You want to be working on cool stuff, not like duct tape.
Yeah.
I remember something that one advice that I give to my students, that Jupyter for me is something that you can join different powers. For example, you can join R, you can use Python and other languages, web programming. So maybe you can use them for one purpose. You can do different things. That is something that I remember that I give to my students.
I think one of the problems with notebooks in their current form is that so many people find them useful as they are. There's not much pressure to make them better, because people like us kind of use them just very casually. But to transform them into something more like Streamlit or I mean, Streamlit's more like the front end, but as Leo was saying, like what happens in the back end, how do you get just a working environment that you can come back to in a couple of weeks' time and it's still working, or you haven't lost the data? I mean, I was particularly interested. I think I never got to ask the question, Leo, but like how you do the persistence of like kernel data. That was kind of really interesting, because that's always a frustration. It's like, oh, I can see the output of the data, but
Yeah.
where's the data gone? You know, in a kind of old notebook once you've lost the kernel.
Yeah, and also actually I want to add something to the previous. So like my past life was as an actual programming language designer, so I thought a lot about the semantics of adding new features to systems. And so the Jupyter lifecycle thing to me is actually almost an issue. It's not so much Jupyter, but how Jupyter works with Python modules. Like, what does it mean to be a modular unit? And it's just like, not to me, it's just like not thought out enough that like Python has modules and then Jupyter has in Python files, but like it doesn't actually all work together. And so, and especially if you think of a software lifecycle. But yeah, like Ian, to your point about the kernel thing, I think there's kind of broadly, if you look at notebook systems, there's two kinds of notebook systems out there. There's the Jupyter world where you have a persistent global kernel where like you have one kernel, it's always on. Like Databricks, you connect to your kernel. On Jupyter, you connect to your kernel, and then something crashes. Sorry, you know, your data's gone. Have fun. I hope you didn't, you know, that wasn't important. And then there's, if you look at like observable HQ, for example, there's these kind of more like data flow systems where each cell is sort of like a node in a graph, and then you can do things like, oh, if one thing updates, you can have like things downstream from it re-update, but nothing else. And then Louis takes this to an extreme level where we say, closer to almost like how like I think our studio does it, where like we do a little more principled, but it's like when a cell will have an output, like, oh, the cell, like in a Python function, you can have a return of like a data frame, or you can have a tuple of a data frame and another data frame, like whatever you want to return. So in Louis, as long as we have that case where your cells return something as a normal Python cell, what we'll actually do is, what it means is, because we actually run each one in an ephemeral sandbox, we'll actually persist that to kind of your notebook state. Just like, imagine kind of like have like a .json for your IPNB. It's basically a JSON file. We'll actually have your file, a folder of artifacts like Parquet files. And then that means that because you have all of your assets and artifacts right there, if somebody comes in the next day, you don't need to wait till a kernel to start. We just load in the Parquet and you're there. And you can actually have parallel cells running in parallel because it's all isolated. So it actually opens up a lot of cool functionality.
That's really good. I think Ryan in SecureWorks has done something somewhat similar, like persisting the output of notebook of each cell into like a base 64 blob, as long as it's not too big, and saving that with a notebook and then rehydrating it, which is kind of quite cool.
Yeah, well, that works until you want to have like half a gigabyte of something.
Yeah.
So we're very much a performance optimized. So if you get like, you know, a million things from Databricks, we'd like to be able to open your notebook in sub-second, you know.
Yeah, sure.
I think the risk potentially with trying to make notebooks more useful in a production environment is we would undermine their usefulness in the experimentation space. And I think there are some production kind of use cases and workflows where notebooks are really good, but I think they are probably fairly limited. And yeah, I think we could keep creating the duct tape and the kind of intermediate steps to kind of get them to a production environment. But again, we'd maybe only be benefiting a handful of people, and the vast majority of people that wanted to take a kind of something built in a notebook and turn it into a production flow might be better off looking at using a completely different service like Azure Functions or something, just to kind of like run the code. So I think it's kind of, it'd be nice if it was easier, but I'm not sure it would really be kind of worth the effort or the potential risk of undermining the brilliance of notebooks in their current format.
Yeah, I think maybe if there was a nicer pipeline to go from your experimental notebook into something that was, you know, like a macroized version, so that people who are not, expert kind of data wranglers, coders could take it and tweak it. It's like, oh, I want the format in this, something a bit more user friendly. That would be a nice thing, and maybe things like Louis are kind of helping in that direction.
Well, this seems like a good use case for Gen AI. We could have notebooks to Python code or Python library copilot to take your hacky notebook and turn it into something a bit more polished.
I've been really impressed by folks have seen either Dagster or Prefect, which are these kind of like orchestration scheduling systems where, like, let's say you do want to have your you want to have your thing run every 10 seconds to scrape something, or like you're doing some OSINT pipeline, and their UX, like they do kind of life cycle stuff, like they have a nice UX, and then like let's say you have an error rate that gets associated with your workflow, and it built out. Other people probably are familiar with like Airflow, for example. These are sort of like successors with just a lot more stuff built out. And to the point about the Gen AI thing, I'd kind of want it like sort of almost like both directions, where it's not like, that was kind of like when I was saying in the talk, was like, I would love to be able to go into those systems because they're so built out, but it's a one-way road. And then now back to VS Code, or like Splunk, was that Splunk SOAR thing, where now there's funny whatever playbook editor thing, and I can't go back.
Yep. So we had another point about like Gen AI questions, like how do people think like the use of Gen AI? I mean, we could talk, there's two aspects. There's like the use of Gen AI in notebooks, LLMs, and I've seen some examples of chat being integrated as like a specific cell type. I think that Azure Notebooks, people have kind of had an example of that. And there's the other aspect is like how Gen AI might help with the creation or doing something with the content, like transforming it into maybe a Streamlit app or something kind of more consumable, or just helping with code samples and stuff. So if anybody has any views about any of that.
Yeah, I'm thinking, so to me, so this is one of the questions that I had, I think, in one of the channels, but to me, it seems that, yes, you can expose, I guess, like an interface so that someone can benefit from interacting with a chatbot that is backed by an LLM, right? Just to kind of get that, reasoning behind it, and you can probably improve the summarization of evidence that you're finding, maybe. I don't know, like it could definitely help you, but I think there are some users that would love to have that with still the experience of, all right, let me take this output, and even though I can have it in a nice markdown format for me to read it, I would love to analyze that. Maybe the agent that I'm interacting with doesn't have a tool for me to do it. I would love to just continue the conversation, but have the tools to analyze it on the fly. And maybe if I need to go back to the chat experience, then I just want to have that in one place, right? So I feel that when it comes to Jupyter Notebooks, I think that some data analysts, I guess, would love to continue using that experience of the interacting with your data, and also have the flexibility to analyze it on the fly. So I think it's like a combination, like a hybrid, environment that we're going to continue seeing. For example, Christian was talking about having a cell, right, with like chatting on it. Louis also, I could see it that you can just type, you get your results, but then you get a data frame or a table. That's how I see it, like now integrated into the whole experience of a notebook, right?
Yeah, I think notebooks are the ideal interface for that chatbot experience, because you kind of have it anyway, right? You have your code, and then you output your more code. It's basically the same format. And I think, particularly in the way we see kind of code generation capabilities from LLMs coming out, it fits really well with the notebook format, because you don't want to necessarily just trust it as is and it's going to be perfect. You kind of want to look at it, and you might want to tweak it, and you might want to test it first. And again, I think a notebook is the right place for doing that. And I do wonder if we see kind of like Gen AI assistants for coding being developed more, whether we will see that kind of Jupyter-like interface become more prevalent in software development generally.
Yep. That's what I said at some point, that you know, when I see projects like, you know, Louis, for example, and you see other companies, I'm not going to mention any names in general, this is right, but in general, I think that there is a lot of trying to solve the problems by providing an interface that you can just chat and solve your whole problem with just chatting. I think it's great. Once again, like, it definitely expedites multiple areas of an investigation, for example, like it truly does, right? But you still need to have this like the analytic, you know, space also, right, with the chatting. So when I see projects like that, like, look, I'm like, all right, I could tell people behind it, you know, have faced those problems before, not only in security but maybe in other areas. So it's kind of cool to see that problem being kind of like approach. The approach to solve that problem is interesting with notebook experience, right?
And I don't know if anyone's used the data analysis kind of feature in ChatGPT, where you can give it a data file and ask it to run stuff.
Yeah.
Whenever I use that, I always think, I wish this was a notebook output, because you don't see the code that's run. So when it's not quite right, you have to rewrite your prompt. And I just give it to me in a notebook so I can tweak the code, because I know exactly.
You can see some of the code, but it shows up like as the process is happening. It shows like you can actually break it down and see like, oh, like what's going on. But as the code is being executed, it disappears. So sometimes I'm like, wait a minute, I had to take a screenshots, put them on the side, and see exactly what happened. Like, so sometimes it does that, and it's kind of weird. Yeah.
Yeah, that's kind of a part of our thesis of like what's going on, is that, you want to optimize for the user, right? And there are different kinds of people out there doing different kinds of stuff. And I think like OpenAI is optimizing for, the non-professional user, they're the non-technical user, and then so they have to have it very minimal. But then for folks who actually need to dig in, like, you're not afraid of Python, you're not afraid of like Excel, like you actually want to do that stuff. Like we think of it as sort of like, my guess is like there's going to be like, and I'm kind of curious who folks will think will win on the technical side. One version of the world is like default Python, and then maybe you sprinkle in LMs and stuff. Like maybe you have a Jupyter cell and then you could call into it or whatever. And the other version is like, in most analyst situations, it's more default literate, and then you have an escape hatch that if you do like, maybe it generates like kind of like how you open the OpenAI thing, but then you have a smoother like, oh, I do want to start editing formulas. I don't want to actually go into Jupyter because then I can't go back, but I do want to be able to edit or resume. And like, so it's more so the question is it default Python? I don't know if we could do audience polls. So do we want like default Python, or default you could talk to it like a normal person?
That's a good question.
Yeah. Don't normal people talk Python?
This panel just got weird.
It'll be kind of neither of those and both of those at the same time, because I think, as Roberto said, kind of everyone's defaulted to this kind of like chat first interface. But I think as we develop more in the Gen AI space, we'll have a more natural set of co-pilots for different situations. So you kind of won't have to choose necessarily. And I think ultimately, eventually we'll get to the point kind of where sci-fi has been, where actually you have this kind of assistant that you can talk to, and it just knows the context of what you're in wherever you are. So you could be in a notebook and ask it, and it will know you're in a notebook and do it. Or you could be looking at an Excel file or something. That's like what I would like to see. Maybe it will just all be chatbots, and that's the only interface we'll ever have for anything. Who knows?
Yeah.
Oh, sorry. Yeah. No, I think one point, I feel like from adoption perspective, the integration experiences has like more user base, because I think people are still, I guess, like running away from Jupyter Notebook and that interface, kind of like overwhelming at first if you have not been doing that perspective. So that's why like probably many vendors that we are seeing like has like this integrated experience within the portal and some of the other places, and then just it's also easier to only do the specific things of they wanted to achieve from that experience. So it's easier to roll out those solutions. But I think like for other user base who have been working with Jupyter notebooks, and they do have like those use cases where I think we need those chatbots to solve like code troubleshooting and everything. Yeah.
Yeah, I was going to say that I think people have touched on this already, but having like a response, a little bit like the way that ChatGPT responds, and it may give you like references at the end, to respond with multiple streams of data, so that you can, as Roberto said, that you don't just have you might get the text summary of what the answer is, but you have published into the kernel all the bits of data and maybe the code that kind of went into making that thing, so that you can click on the data. And that will maybe go into the context of the next LLM prompt. It's like, we'll do something else with the data, or let me do a query on it.
Yeah, to me, that aligns directly with how for the past, I guess, 2 years, what I've seen in the community a lot, especially the first year when, we all got introduced, I guess, that the security community got introduced to ChatGPT or just any other interfaces with this generative AI technology, even though it has been years already for some of this. But it seems that for the past 2 years we have been always thinking about ChatGPT just as a question answering. But I think that we're getting into this process now where we need to take advantage of that reasoning, of that loop of step 1, step 2, step 3, right? So when we interact with these interfaces, usually the experience is not that, right? Where you could actually be either part of the loop of steps from 1 to 10. I want to know at what step maybe I can provide input and then continue. That's what I'm going to see, I believe, more in the community in cybersecurity, because I know that we're usually behind a lot of these other applications, right? but yeah, so having, for example, every response that I get from a chatbot, I would love to have a button that says natural language and maybe structure or JSON, so that way I could actually either be part of it or see how it's being structured and maybe adjust the structure for the next step. I don't know if I want to be part of the reasoning, right? The whole but that's what I think is where hopefully in the next year or two we start thinking more about structure, output for this type of experiences, but to take advantage of the reasoning of LLMs and not just the tell me more about what you know. It's actually reason over my data, and that's what I love, the continuously learning, because that's where we need to go, right? As you investigate, you're actually learning something new, right? So
I wonder if in a multi-agent Gen AI model, whether a notebook could be one of those agents, albeit a slightly dumb one, kind of taking input and output from the various other agents and being part of that reasoning chain, perhaps where there's not a good LLM agent to kind of do the job currently.
Yeah, I can give 2 examples here that might be I think speaking to both of those. I very much agree. One is and I think Roberto, you're alluding to it earlier. One of the things when we talk to an LLM, they're good at transforming stuff and doing rewrites and edits and looking at the effect of it and making further decisions. And so a funny thing to do is realize, hey, code is data, right? And so your notebook is data, and your dashboard is data, and your automation is data, and it's a configuration file. And so what I was showing today, and I think the other examples are kind of more this chat style where you're just continuing the conversation. But for example, now that we have our core dashboarding stuff out, there's no reason we can't talk to Louis and say, hey, create 2 panels there, remove that one, and actually rewrite all of the queries into my dashboard to now focus on this time range and on this subnet, and so that's more that transformation. And then the other one, and then the other side, and this is where I was trying to allude a little bit to this notion of managed investigations. I do agree with what Roberto is saying, is that we're starting now that single step LLMs and single step agents and tools are getting at a pretty good quality. So something I'm using increasingly personally is in OpenAI, their web agent where you can have it browse and do something with it. But it's like horribly limited. So for me as a technical user, I'm like, I know I can't really do much with it. And I know that for the stuff we're building out in Louis, I know we can do much more interesting things because, you know, we have that control and power. And that's where, and so here's like a simple example. Imagine the LLM can ask you a question backwards. So you can say, hey, you know, hey, do this kind of web task. And then if you ever hit this kind of uncertainty point, ask me a question. Right, and that's actually a program, right? And that's kind of a multi-step or multi-turn agent program. And then now all of a sudden you're assuming a lot of things about like its ability to do that, its ability to have interfaces that and UX controls and semantic controls that kind of feed back into the interactive process. And I do think we start going well beyond like a Jupyter notebook with a chat cell, like if you're going to support this kind of stuff.
Yeah. Well, that to me, once again, like that's where the conversation, I think when you think about notebooks now and LLMs, it's like it's like, how do we improve this whole experience? And I'm pretty sure in the next year, I mean, this year and following year, you know, we're going to see like more of that from either companies exposing these, you know, features to their products. So yeah, and hopefully for security analysts, we can see more of that, right? All integrated. So.
So I'm running out of questions. One I had that I did sort of ask Christian a bit earlier on about the. I think there's more that we could talk about on that question as well. But like given the fame of Gen AI and LLMs over the last year, it's kind of pushed all of the other ML stuff, just one ML stuff like deep learning, kind of traditional statistical models and stuff like into the background. But obviously that still does stuff, you know, that you would never hope to be able to do in an LLM because it's not like a text-based problem. Like so traditional ML hasn't died, but like you know, how does it survive and swim and get integrated into the kind of Gen AI world? There's maybe tools or something like that as a LLM can use. I think that's because now when people talk about ML or artificial intelligence, they just mean Gen AI, really. So, anybody have any views on that?
Maybe you know, first.
Oh, don't worry. You know, generative artificial intelligence happened a few years ago. I remember when I began exploring this, that it is about the use generative adversarial networks, use of GANs. So right now we have large language models because it is something where we can use text in order to translate different things. So I think this is one way in order to connect facilities. So the thing is how the text or how you say this, all the humans can produce text for some of them. So the thing is how we can connect the great part of the humans with the computer. So I think this is a good approximation. That in order machine learning, prediction machine learning doesn't. But this is today. For example, the recommendation system is a traditional machine learning. So it is going to happen. The thing is, for example, in cybersecurity, you know, we have an orchestration of different tools in these things and machine learning models in order to filter, for example, the false positives and different things. So it is how we can use large language models in order to provide, how you say this, or to enrich the final output to the user. I think so. And one of the things that Roberto mentioned that what came in my mind is, for example, how to open this black box, because large language models are black box. So who can provide that this system provide us, more insights, more interpretations about their decisions. So I think that there is the difference between traditional, deep learning is not is black box, but in another way we can use regression, linear regressions, or something like that that works well. So that it depends on the situation that we need of the business case.
Yeah, I mean, there's a scale thing here too, right? Like, let's say we're trying to do some detection engineering, we're doing like gigabyte a second stuff. My budget is not big enough to run that through an LLM. Maybe the Microsoft people here are in a different scenario, but even like when we're doing like LLM pipelines, we'll often do, for example, a spam filter at the beginning just to kind of screen what goes in. And like I was showing an example earlier today, like a UMAP that we're doing for anomaly detection, and like the LLM, like we're seeing from an authoring perspective that you can kind of view it as like neural architecture search, where like almost like a stand-in, where the LLM is kind of figuring out like kind of the planning stage of which algorithms we should do. But from like what the ultimate detection or decisioning, there's a good chance we still want to have those like other statistical or deep learning methods that are getting generated, whether it's from a quality perspective or just a performance. Like, you know, I am very unlikely to give up random forest and UMAP in the next 2 years. I'll say it like that.
I think it's a very good point about the kind of what's the right tool for the job. And as Ian has said, with LLMs being kind of front of mind, it feels like everyone's default is let's give it to an LLM, whereas actually maybe 50% of the cases you'd be better off with something simpler, whether it is some predictive AI stuff, or whether it is just some Python code rather than having all the inference costs. But I still think we've got a way to go on the LLM hype train before people kind of realize that.
Yes, for example, something that I was talking to my brother. So my brother is trying to start blogging about the traditional ML, and also not a versus or like from this to this, but actually showing where each piece actually fits at the moment, because I know that it changes and it's going to change. So for example, before, when I was this last year, actually, I was trying to dive into how can I do some of the things that I was trying to learn with traditional ML, with generative AI. Like I was just, like very naive or starting the field, right? Like I'm actually new in the field. And right away, I thought that I could easily just pass a, like a security event log to the LLM. And yes, it can pick up certain words. It could actually tell me, oh, based on this word, this sentence, it looks like this is a, the creation of a process. But it is not actually, what I learned is that it was not actually fully understanding the whole log and actually taking the meaning of the log as a security event log, for example. So when we started talking about LLMs until last year, like July and August, I was trying actually to look for like what models would actually understand logs very well. So to me, like that's the first thing, in my opinion, that we need to understand is like if we try just to pass a typical log to an LLM and then trying to extract pieces from it, truly understand the log, I think that we are seeing that just happening, right? So I don't think that we are there yet with a lot of these models that are being released, like open models as well, that every day I see someone that creates or like shares a new like open model because they were able to take another model and then improve it. And there's a lot of that when I follow people outside of security. But then always, to me, I always look into like what are the things that this could do. And to me, it's hard to find even right now like an open model that could actually help me to even understand my logs as they are, right? And I know that Leo, you mentioned before that there is already like things that one could do, right? And also Louis is like pretty much doing that, right? But to me, like when somebody starts saying, can we use Gen AI for this thing? The first thing is like, can the model understand actually the data, like truly understand what's going on? Or that to me is like the first question. And if the model that we're using is cannot even parse a log properly to understand it, then that's probably not the best use case for that model, right? And then, of course, traditional ML, in my opinion, is solving other issues. Like when you think about generative AI, a lot of the products that I'm seeing are directly to solve the incident experience, like the investigation, to summarizing incidents, maybe explore scripts. It's just trying to help the analysts to expedite their process. But when it comes to analysis, like to actually truly analyzing data, to me, I haven't seen too many use cases like that, right? So and to me, it also seems that generative AI is being applied usually like after the fact. So traditional ML to me is still trying to be used pre, I guess, exploitation, because we're trying to identify all this large amount of data. Let's just identify some anomalies right away and try to see if we can trigger something. And then once something triggers, now we're trying to use generative AI. And once again, it's just my experience, how I see some of the companies trying to do it. I would love to see how generative AI over the years starts getting more into the other pieces of an investigation. And the last thing, of course, what Leo was saying, we cannot just throw all the data to an LLM. So it's we cannot just do that right now. It's too expensive. So different challenges, right? When someone say, where do we apply which, right?
I wonder, as you said, Roberto, kind of helping people identify kind of process improvements is one thing they're potentially good at. I wonder if a, say, threat hunting team that has a lot of these notebooks, which they're kind of like struggling to organize, or having a lot of ephemeral knowledge in, I wonder if this would be a good task for an LLM to go look through them. What are the common steps each people are doing? Like, what are the bits of code that would make sense to kind of move into a library, because everyone's just kind of writing the same thing over and over again. That sort of kind of like optimization. Yeah,
that's basically that's a wonderful characterization of learning Louis, right? About the whole, like, as soon as anyone writes Python or any useful techniques, like that should be part of like the hive mind that you could talk to, interface, manipulate. But actually, going back to Roberto, like one of the wildest things I saw about like maybe a year ago, like I haven't really followed the space in this one, but more recently, but it's one that I definitely want to go back to, is I think there's something like, I don't know, like 100,000 models on Hugging Face, some ridiculous number. And then more broadly, there's like, like in Scikit and all these like ML libraries, there's like all these functions, right? And so there's this crazy paper that said like, hey, you can talk to your LLM and it'll do some data analysis for you. But one of the main things it'll do is it'll try to figure out if there's like a data set and a model on Hugging Face that it should apply in a problem. And so it's like automating the data scientist.
Wow.
So cool. Like, and whether it's like a LLM model or like a older neural network model, or it's like a classical ML model, like it doesn't super matter. It's just Python, right?
Yeah. I was gonna make a point about like, so one of the things when I years ago started messing around with things like isolation forest is like classical ML models expect numbers as inputs, and traditionally with like a security analyst, you're dealing with text mostly. There might be like occasional things like process IDs that are not very useful, but you're trying to understand like command lines or bunches of like authentication properties. So having an LLM potentially analyze that, I think, as you were saying, Leo, and saying, well, what's the best way of rendering this into something that a random forest or just k-means clustering could understand and do something with, I think would be very useful. It would potentially open up that kind of capability to a lot of people who couldn't, wouldn't otherwise be able to use it. So if they were available as like tools that an LLM knew about, it's like, oh yeah, I think that's what you said before. Like, hey, you should be using this, and this is what you should do with the data. Here's some Python to transform these 4 columns, which seem to be the most interesting, into a numerical representation that we can actually apply this to, and then here is the result.
Yep. So we are what 8 minutes to the end, right, of this panel, and I was thinking, any probably last thoughts? It seems to me like notebooks, like Leo was mentioning in his keynote, like they're not gonna die, right? It's actually so to me, like I wanted to get back to the conversation of notebooks at least for the past 8 minutes. If anybody has any thoughts into like someone that it's new right now, like watching this, and they were like, "Wait, I joined for notebooks, and now we're talking about LLMs." It's like
well, actually, I've got maybe feel free to like squash this, right? But like,
sure,
this is sort of actually one of those like stupid practical questions, but how do you do notebook security, like sharing and whatnot, like whether it's like data or code, or especially in a team? And yeah, how do we do notebooks safely?
Think about Ian and Pete. Maybe you guys were sharing notebooks in the past.
Yeah, I think there are a few challenges. One, I think a big one is data at the moment. One is our secure data sharing format, and pickle files have been used a lot in the past, but are horribly insecure in many ways. So I think that is probably something we still need to answer. I think the other issue at the moment is less around storing, more about using. If you kind of focus on what red teamers are interested in at the moment, Jupyter servers are pretty high on their list because they are very, very easy to get into. They have a kind of a lot of issues, and often notebooks are full of credentials and other great things. So I think there are, like, generally around notebooks, thinking about how we kind of secure the whole infrastructure is probably a topic we don't address enough. But I think from my past experience, one of the biggest things has been, can you secure them in a way? Can you share them in a way that doesn't require data to be shared with them, like having a secure source you can connect to? And then the second piece is, can you sanitize them and secure them in a way that you can share it without kind of like accidentally leaking credentials or other sensitive information? And I think for that to happen, teams need to kind of implement some of the robustness and pipeline work that they would do with kind of traditional code check-in to notebooks, which I don't think people working in notebooks do quite as rigorously as they should right now.
I had a more specific question. I don't know, as someone who's newer in the industry, I'm constantly asking folks for their favorite kind of blogs or resources to learn about these things. I'm constantly in these talks and speaking to these super senior people who have this sea of knowledge in their brains about what's trending and what's new. And when I look at Twitter, it's just all a sea of technical content. Some of it's really fascinating. Some of it, I can't gauge if it's garbage or not. So it's, I don't know, if you have any favorite blogs, resources, podcasts, folks in the industry who you tend to really like appreciate their content or recommendations to build up like an arsenal of learning and then regular kind of media content to feed your brain, let me know. I'd love to hear.
For folks who remember what Django is, so I guess in IT we see it a lot. But apparently, the Simon, I don't know his last name, Williamson, something like that, some sort of W. So the creator of Django, so he made it at some, I think he was like at a newspaper or something. But then he went off and did, I think, a project called Dataset, which is like another take on private data analysis and sharing. But he's been writing a lot and playing. He actually has a tool called LLM, which is a command line tool here. But like more broadly, from a tooling perspective, especially if you're on the Gen AI side, I think he's done a really good job of, as he personally explores it. And I think Roberto actually does this pretty well to an extent. But like this guy is like, it's almost like his full-time job or something. But yeah, as he's been learning, he's been writing up on the Gen AI side. On the Jupyter side, I can't really point to, I don't know, maybe other people have better.
That's crazy that you mentioned Django, because I actually used it for a web app project 2 years ago in college. They still, I don't know why they had us use Django. A lot of us were kind of baffled, but it's cool.
We use it. We use it. So
oh, nice.
I shouldn't bad mouth it. Like we literally use it. So
oh, no way.
And we are happy with it.
Nice.
Nice. Yeah, and to me also it depends on the for example the so I wouldn't say the problem that you're trying to approach, but the area that you might be interested the most. So for example, some of the open source tools out there, for example, when you talk about, let's say, Llama Index or like LangChain, right? So when I follow those two, Twitter handles, for example, I see LangChain. It goes now is going a lot into like trying to expose an experience to build agents and how you can actually even build it in a way that you could see what's being executed for every single step. Like they're trying to show you more context around it. And then there's multiple people that follow that. And then the same Twitter account follows other things that are related to that. And that's how I find the network of people that I can learn. Llama Index right now, as far as I could tell, based on my Twitter feed, they've been going hard on trying to not solve but share some ideas to how to do, for example, like retrieval augmented generation, like multiple techniques. Like they actually have modules that are probably more robust in certain areas. So, and then I go into like who are they actually retweeting about. And like LangChain, for example, recently was tweeting about Neo4j and like structure, using agents for structured data, for example. And then I found this other guy that I didn't even know about. And then I bought a book from that person. So that's how I go. I try to go to the open source project. For example, now I'm following Louis. So to me, I would love to know like what Louis is tweeting about, like who are they actually following as well. That for example, if I follow Louis right now, my head is I'm going to be probably seeing more tweets about people using LLMs and agents, or in general, Gen AI, to approach it to cybersecurity, something that you don't see as much with these other open source projects, right? So that's how I would build, to be honest, Diana, the knowledge paths, and it works for me, and that's what I like to do. Open source, and then who the open source is supporting.
Roberto doesn't sleep though, so he has a lot of capacity to absorb this information.
I try to I do sleep, but yeah, some nights are pretty rough. Yes, I want to say yeah, but no, I think also managing your time, and for those that will be watching this video later, managing your time is super important, because otherwise, like you won't be able to operate either at work. So it's super important. Anyways, so maybe on that note, I don't know if it's already 4 p.m. my time. Do we final thoughts, or how do we want to do this?
I had a little kind of thing to call out to anybody still watching. If we're always looking for like people to collaborate on this, because we all have full-time jobs, but on future Jupyterthons, if anybody wants to get involved with the organizing, getting speakers, just running the show, we'd really love to hear from you. So don't be shy.
Yeah, this is a truly, like, seriously, this is like a truly community, by the community, for the community. Like we just, we all have, of course, a very busy schedules with work. Everybody has, even with life, right? And we just meet a couple months before, we talk about it. We try to figure out what would be the best thing to maybe do and improve a little bit some of these things. But it's truly just us, like security researchers, and trying just to share a little bit. Sometimes I say, well, 2 days of the year, I think it's great. I could actually, but it takes months of like trying to figure out all of this. And for that, I want to say thank you so much to all the speakers that also truly took the time to share, and all the people behind this, also the ones that you guys been seeing throughout the conference, some new faces from the past couple of years, is because they're also, were super nice to take some other time, and it's amazing to see this continue happening like every year, right?
That's great. Thanks everybody and all the speakers for their flexibility, shifting times, for tolerating the not very high quality studio production times.
Hey, that's when so hopefully next year, if anybody wants to support the conference too, that would be nice. But I think you're gonna see us still for several years, right, Ian? I would assume Ian, Pete, everyone, right? We're still doing this. No sponsors, but it's okay. Like we figured out somehow, right? It's amazing. This is what I like about all of this, and truly like done by the community, right? For the community. So, yeah. All right.
Cool.
Well, thank you so much, everyone, and enjoy the rest of your day. Enjoy your weekend, also. So
yeah, thank you to all the organizers. It's went really well. It's a lot of fun.
Yeah, thanks everyone.
Thanks.
All right. Thank you. Bye-bye.